Welcome to the live stream of the Terran 1, which is Relativity's new vehicle, which they are building and going to be launching today, hopefully. They had a chance to launch it 3 days ago, on Wednesday, I believe, and they didn't quite get all of their pieces together. They had a couple of issues. In the end, they ended up having to stop the count just 70 seconds before the rocket was ready to take off. But hopefully today, everything is all evened out and ready for an actual launch. And there are a lot of cool things about Relativity's vehicle, the Terran 1, which we kind of are interested in covering. A little bit of background on me. I am Josiah Coy. I am a space engineer, and I'm also the chief engineer of a group called ASTRA. Our logo is right here on my shirt. And we're just a student group out in Bremen, and we are one of our main goals is to build a rocket which will go to space. And of course, in order to gain some inspiration from the community around us and from other launch vehicles that are out there, we like to stream these launches just for a little bit of awareness of some of the cool things that are happening in the commercial aerospace market. And Relativity Space is a really cool company that are doing some really interesting things with rockets, and they could be revolutionary and actually change the way that we actually design rockets today. So we'll see if this is actually going to be a success and if they can improve the technologies which they're demonstrating on this vehicle. So what exactly is interesting about their vehicle, and where does this vehicle fit in with other vehicles? Let's get a little bit into that. So just looking at the statistics for the vehicle, we see that it's about 35 meters tall. It's about 2.3 meters in diameter. And it has a lifting capacity to low Earth orbit of just over a ton at 1,250 kilograms. That puts it into the medium launcher class. So it's not a small sat launcher. It's not a heavy lift launcher. It's kind of in that medium zone, which is between like 1 to 10 kilograms, 1 to 10 tons to low Earth orbit. So this puts it in a very interesting competitive environment where there aren't too many vehicles that it's competing against. So we'll see if this is actually going to be a niche that is going to be valuable in the future. One thing is for certain, which is that there are lots of satellites that are kind of in this mass range, so it can be a very interesting place to compete. It's a two-stage launch vehicle, which means that it has a core, which is kind of on the bottom, which is like most of the bottom of the rocket there. And then there's an upper stage, which is kind of like a second rocket, which sits on top of that first one, and it'll be ignited once that first one runs out of propellant, which is a pretty standard design for a lot of these launch vehicles these days. But what makes Relativity Space a little bit interesting is that they're actually utilizing some technology on this vehicle, which is brand new, and that's with 3D printing. So you can see here, this is their factory. They have these 5 bays there, and each of those bays has these fancy 3D printers in them. And there's never been a company which has completely 3D printed a launch vehicle before. So Relativity is seeking to be the first company which will launch a fully 3D printed rocket. It's pretty crazy because these 3D printers are not printing plastic like, we're used to. They're actually printing aluminum, and they're printing aluminum on these giant size scales. So it works pretty much kind of like a regular 3D printer, except their filament is aluminum, and they're using a lot of fancy software technology to make sure that they can actually form these giant structures without any deformations and keep everything level and keep everything fitting and everything. So yeah, if this actually turns out to be effective, like think about how much easier it's going to be able to build a rocket, because you don't need thousands of parts in order to make these complex systems. You can literally just print all of these parts in just one big part. And that's kind of the idea that Relativity is trying to play with here, where they can vastly simplify the construction process for a rocket. So we'll see if this is actually going to turn out to be successful. They're going to talk a lot about the technology that they put into this, so we'll probably hear a bit more about that once their live stream starts up. Yeah, we're definitely interested to see if this technology will be effective enough to work on a launch vehicle. If it is, there's a lot of interesting future applications that this has, much beyond just being a launch vehicle. So there's going to be like a bunch of companies, a bunch of people that are going to be interested in this technology, because imagine what you can create with a metal 3D printer, an aluminum 3D printer that works like this. Lots of cool, interesting future opportunities there. If you want to know kind of how the 3D printer works, this is a time lapse here that we have. You can see how basically it's just laying down layers like a regular 3D printer would, but it's using, of course, aluminum and this kind of fancy robo arm, which allows it to have access to the whole print bed. And you'll notice also that the print bed is rotating because it's building a cylindrical structure, so you don't have like that, XY axis type of movement that you'd see on a normal 3D printer. Yeah, this is actually their innovative way to approach building these giant structures out of metal. And just for scale, that part that you're seeing printed there is about 5 meters tall. So it is a giant part. It'll be definitely interesting to see how this technology plays out in the future and if this will actually work. Anyways, moving on to a little bit more about the vehicle. The engines of the vehicle are these 100 kilonewton engines called the Eon engines. They are also 3D printed. You'll notice this being a theme for the entire vehicle. Everything is basically 3D printed. In this case, though, it's not 3D printed with that fancy machine that we saw before. It's just 3D printed using the standard metal 3D printing method, where you have like a dust layer that gets put over top, and then you use lasers to actually print the metal onto the bed. Not to say that it's like not cool. It's definitely still awesome that they're 3D printing it like this. Interestingly enough, though, they are actually using methane and oxygen for their fuel and oxidizer combo. This is a bit more of a newer fuel oxidizer combo that's been popping up in the last couple of years. So the reason why, like typically you would see RP1 as the fuel that is used for rockets, very, traditionally. But lately, methane has kind of been more the choice. And the reason for that is that methane tends to give you a little bit more specific impulse, which means that it's a little bit more fuel efficient, so to say. You get more bang for your buck. But you also have to deal with handling methane at cryogenic temperatures because it's a cryogenic fuel. You don't have that issue with RP1. So it's kind of like this balance between complexity versus getting a little bit more performance. And this AN engine has tons of history. It has over 500 tests. When you 3D print a rocket, you can just, bang these things out and get lots of testing underneath your belt. The engine is also operating on a cool cycle called the expander cycle, which is basically describing how the fuel flows through the engine. Basically, it's using the heat of the energy of the combustion inside of the combustion chamber in order to actually power the pumps that are pumping the fuel into the combustion chamber. So it's kind of like using its own energy to continue running itself. And this basically eliminates the need for pre-combustion chambers and is actually a bit of a simpler cycle, while also still being able to deliver you a lot of efficiency. Typically, these engines max out at around 100 kilonewtons, and you'll notice that is actually the thrust that they're rated to here. So, definitely utilizing this technology to the fullest. Here, I went a little too far. Here you can see one of the hot fires in action. And you can see it's quite a... it's just a typical hot fire environment there. They're actually testing this at the facility that they have in Florida. So basically they just strap it down. You see those cords that are holding the booster down? They basically just strap it down there and pretend as if it's an actual launch, and then hold it down while they ignite the engines. It's kind of better to do it this way in a way because you can kind of almost pretend like it's an actual launch. So hopefully that helps them in terms of actually preparing themselves for doing an actual launch in real life. So we'll see if they're ready this time. Like I said last time, they tried on Wednesday. They had some issues with the tank pressures, but hopefully they've ironed through those issues today, and we'll actually get to see an actual launch. So yeah, right now we are a couple of minutes away from the start of the live stream from Relativity. So we'll be tuning into that once we get a chance to see what's going on there. But I just want to let you know to start, I don't have a clock up that says exactly when they're going to launch. And there's a reason for that. This is a test launch, so it's kind of a large window of potential of when they'll actually launch the vehicle. They have a window that basically starts in about 20 minutes, which is 6 p.m. UTC, and it'll extend for 3 hours from there. So anytime in those 3 hours, we could see this vehicle launch. That's the time that they have cleared with the FAA. You'll see that sometimes, like, it could be in this situation that they have their clock up and it's going to launch in 20 minutes or something, and they might call a hold or something like that. This is quite typical in the early development phases of these rockets. So don't get freaked out if that happens. They will often try to recycle and try again relatively quickly. So it's only once we get to the end of that window that basically they'll decide, okay, maybe we have to scrub for another day. But yeah, don't be disheartened or alarmed if this type of activity happens. It's totally normal. This is, again, the first vehicle that they're trying to launch, so they're learning about their system as they do this. So anything could happen. On that note, let's talk a little bit about what will happen once they actually press the button and get this thing launched. So here you can see the trajectory that the vehicle plans to take at T-0, which again is not really known exactly when that's going to be, but it will be sometime in the next little while. The engines will ignite, and then basically that will go for about 2 minutes and 45 seconds. And then you're going to see the main engines cut off, which means that first stage of the vehicle will be done and out of fuel. The second stage of the vehicle will then separate from that first stage, and then that second stage will ignite, and then that stage is going to burn for about 5 more minutes, and then essentially that will be the end of the mission, and it'll be in orbit. There are no payload fairings on this particular demonstrator vehicle because there's no actual payload on the vehicle. Instead, there's just a little ring that they had that was their first 3D printing attempt, and that is going to be their first payload that goes to space. But it's not actually a real payload where a customer is paying for it. So there's no need to protect it so much with a nose cone. So they just have a little nose cap on the top, which covers that little ring. Hey there, Eduardo. Great to have you in the chat. Looking forward to hopefully seeing a Relativity launch today. So that's what we should expect today once the launch signal is given. Yeah, we have some good cameras on the launch location, so we should see some good tracking shots of the vehicle as it goes up. But keep in mind that the second stage is probably going to be in a situation where you might not get all the best shots that you like. It could the camera could kind of like sputter and you'll maybe lose camera video feed or something. This is also normal. They are prioritizing like information and data that comes from the vehicle in terms of the vehicle's performance. So like if the video feed goes out, then they don't really care. But don't assume that means that the mission went badly. Obviously listen to the broadcasters about what the health of the vehicle actually is. The video is not going to be a very good, reliable indicator of anything in this mission. Well, all of this is about the Terran 1 right now, but there's actually another vehicle that Relativity is developing, which is potentially maybe like the main purpose of this whole discussion and this whole development plan, which is called the Taran R. And you're going to hear them talk about the Taran R quite a lot because it's kind of like the the next thing on the horizon. So what is this Taran R? Well, it's actually a much bigger vehicle. So here you can see the two compared beside each other. So on the left there is the Taran 1, and on the right there is the big Taran R. And the Taran R is going to be like an upgrade to the Taran 1, and it's going to be hopefully fully reusable, which means that they're going to land that first stage back on the ground, kind of like the Falcon 9, how it lands itself. And then that second stage is also going to be reusable. So they're going to plan to fly it back like Starship, which is, of course, lots of talk, lots of big words. But first they have to, of course, launch this Terran 1 successfully. That's the first part of their development. Here you can see they've actually already started to print some Taran R parts. This is the bottom of the base of their tank, I believe. And you can see just how wide that 3D printer can go. Like this part here that they're printing is, I think it's almost 6 meters wide. Could be a bit more. So it's quite incredible, like the size of the structures that they can create with this 3D printing technology that they have. Yeah, so in the next couple of years, maybe 2025, maybe a little bit later, we should see a Taran R launch, and hopefully be competitive with things like Starship. Yeah, you can ask about ASTRA's project whenever you want. I'm always happy to talk about it. Do you have any specific questions that you have? I'm always happy to answer and talk about it. Yeah. So feel free to ask whenever you want. One thing that I'll show you here just before we jump back here, how does Relativity's Terran 1 compare to other launch vehicles? Well, it is, I would say, roughly comparable to the Firefly Alpha, which is another medium launch vehicle that's coming online. It has had one successful launch already, but other than that, they're pretty much in the same kind of area of development. You'll see that the Terran 1 is a little bit taller, it's a little bit wider. It can handle a little bit more payload to low Earth orbit. However, the cost is actually a little bit cheaper than the Firefly Alpha at just 12 million versus the 15 million that the Firefly Alpha is charging. So that means that I think that the Terran 1 is probably going to be pretty competitive in the environments that it's in. And if it's successful, based on its 3D printing technology, I think that its cost could even come down lower than the 12 million. So that'll make it a very interesting launch vehicle for maybe even competing against potential customers for SpaceX. Could be interesting. So yeah, that's kind of a brief overview of the Terran 1 and what we should be expecting to launch today. But as I said before, don't be too hard on the Relativity team, because of course this is the first launch for them, and there could be upsets or interruptions, holds, delays, so be ready for anything. So why are we bothering to solve the tank's bolting problem? Why not just glue the ends in or wrap the tube into the aluminum ends in the first place? That's a very good question. I'm asking that question myself sometimes these days. But I'll give you two answers as to why we're doing that. So first of all, the design of our tank and our bulkheads is specifically designed in order to be working for a combustion chamber. So when you're testing a combustion chamber and you're actually putting it on the test stand and doing static fire tests and, you know, trying to do many tests in a short period of time, what's important is that you're able to rapidly iterate, like rapidly switch between, change out like propellant grains and things like this. So if you don't have a solution for that have a system set up where you can do that quickly, it's not a very ideal system. So the bulkhead to the CFRP casing is kind of with bolts and stuff is kind of the easiest way that we had in order to rapidly switch propellant grains in and out of our combustion chamber. we could wrap it all in, but then basically you have like one piece and you test it, and then that piece is kind of like done, and then you have to like get a new one, like you can't just like switch out a propellant grain and then like you can use the same casing and everything. So because of that, we decided, maybe it's better to try to, solve this sealing problem on the tank so that we can use the same technology to make the combustion chamber. For the actual oxidizer tank itself, we'll probably end up just wrapping over an aluminum bulkhead because it could be actually easier, but we'll see. In the meantime, let's switch over to the live feed. I think they've just started up, so we'll jump in and see where they are.
We'll be bringing you live coverage from Launch Complex 16, which is our launch pad here at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Taran R.
And I'm Arwa Tazani-Kelly, Technical Program Manager for Test and Launch at Relativity Space. I'm responsible for supporting the teams that design, build, and operate our test and launch sites across the country for both our Terran 1 and Taran R vehicles, including operations on the stages, engines, and propulsion components.
So you'll notice that we're about 50 minutes away from launch. It's just up there in the top left corner. I think that's the countdown clock to the launch.
Initial attempt, we ultimately decided to scrub due to propellant conditioning issues. Before we get underway today, we want to share a bit more detail and explain how it impacted our first attempt. During Wednesday's operations, a ground equipment valve was malfunctioning. This prevented us from having adequate control over achieving the cold temperatures we aim for with our liquid oxygen. The team has since fixed this valve and incorporated additional mitigations to get that liquid oxygen, or LOX, to remain at acceptable temperatures. Additionally, we've seen questions about why we opted to schedule our next attempt today as opposed to going again on Thursday. The team was able to quickly repair that ground support valve, so that wasn't the cause for the delay. Instead, it had to do with our propellants. For those of you less familiar with Methalox propelled rockets, our liquid natural gas is mostly comprised of methane. But there's also a little butane, ethane, and propane, which are higher order hydrocarbons. As such, methane, being the simplest molecule, boils off faster, lowering its concentration over time. When we load propellant, we do so in a way that achieves our optimal methane levels. If we were to offload and reload those same propellants after a scrub, our methane composition would be off. Instead, we bring in fresh propellants, and the fuel then needs some time to level off to the right compound mix before we make another launch attempt. The good news is that propellant loading is proceeding smoothly today with no reports of issues with our valves or our propellant temperatures. Now we're currently at T-minus 50 minutes and counting. I did just receive confirmation that propellant loading is wrapping up for both stages. The range is green and the vehicle is healthy. However, we're keeping a close eye on upper level winds right now, since earlier forecasts were indicating marginal conditions for today's launch attempt. We use a combination of data from global forecast system modeling and real-time data from our weather balloons, which we are releasing periodically. We do this to determine if enough thrust vector control, or TVC margin, is there to overcome the atmospheric wind shear as Terran 1 approaches max Q. While winds at ground level today are acceptable for launch, remaining between 15 to 20 miles an hour, the upper level winds could impact our ability to gimbal the engines enough to keep us on course for our intended orbital trajectory. Current data is indicating we are a go for launch, but this is something the team is continuing to monitor.
Thank you, Arwa. Arwa will provide regular status updates.
So it looks like the weather is potentially a issue for today, just because of those upper level winds, which are always a bit of a struggle for these types of vehicles, the commercial vehicles anyway. But yeah, another question. Are you planning to test electronics, communication, and recovery systems on a smaller 3 to 5 kilometer rocket? Yes. And there's actually two opportunities for testing of these systems right now. We're first going to perform a drop test in about a month here. And basically what we're going to do is we're going to take our nose cone and we're basically going to throw it out of a helicopter, which is going to be flying at 3 kilometers. So that's going to test out all of our electronics and our avionics systems. It'll also be testing out our complete recovery system. We've actually already tested our recovery system by dropping it out of a plane, which was flying at about 600 meters. So that's already been kind of partially tested. But we want to test it to a little bit higher and more extreme conditions with the 3 kilometer drop. So we'll have that helicopter drop. In addition to that, we also are hard at work trying to apply for launching our rocket at EUROC, which is a European rocketry competition. And that happens in October. So we're hoping to be selected, and we're developing a rocket right now, which will fly up to 3 kilometers. So of course, on that launch, the entire system will be tested, which will include the avionics, the communication, and the recovery system. So yeah, hopefully our system will be fully tested and we'll be ready to basically push forward with the Transcendence launch.
On the back of a coffee receipt to the 1,000 plus full-time employee company we are today.
Hi, I'm Tim Ellis. I'm CEO and co-founder of Relativity Space.
I'm Jordan Noon. I'm CTO and co-founder of Relativity Space.
And we are...
So yeah, we're not actually going to go on a 3K solid. We're actually developing our own rocket, which will be in the 3K category. So it'll be a 3K SRAD. And it's going to be very similar to the Transcendence engine, just scaled down to about 1/10 of the power. It's also going to run on paraffin wax and nitrous oxide. You can actually see right behind me here, this is actually the propellant grain for that vehicle. So it's like, not gigantic, but it's fairly sizable. So yeah, it's just going to be running on paraffin wax. This grain right now is a combination of paraffin wax and hot glue gun sticks. So hopefully that will be an effective rocket fuel. We'll be testing that engine in 2 months from now. We have a static fire test date in May. So we're right now hard at work trying to get ready for that. But yeah, we'll see how that goes.
Photo of a Starbucks receipt where we wrote out the original vision of Relativity. Really, we knew building our own 3D printers, which had to be the world's largest 3D printers, was one of the first things that we had to figure out. So we spent the first couple of years really refining that technology.
The 3D printers are really the whole thing
figuring out
about Relativity.
How to build a finance team, get customers, get any traction at all, really, just to start to breathe life into this vision that we were building towards, and having those first employees really start to define the values and culture of Relativity. Our first engine tests, our first igniter tests, our first Stargate prints of full-scale hardware, and man, I'll tell you, some of those early prints look like piles of metal and pretty crappy, so we really had to figure out how to refine the technology.
It's really crazy how they managed to figure out the aluminum 3D printing. It's really, really revolutionary, in my opinion. It creates a whole bunch of possibilities.
Those early days, there were a lot of hard-won battles, but we learned really, really quickly and really started to hit an inflection point about 3 years ago. Sending that email to Mark Cuban, I just felt we had absolutely nothing to lose. 3D printing is the future. I really feel so lucky that we live in a special time where we actually have the tools, the momentum, and the ability as a company and as an industry leading humanity's future in space. This is the year we're doing it. We've got tons of great team members working on it every single day, and I believe it's a challenge for any team, but for our team, we've got nothing to lose, so I'm very excited and humbled by the people that have joined us and what it means to actually build this thing together.
By the way, they are hiring. So if you are in the California area and you think this is cool and you want to participate in building rockets and you're an engineer or something, shoot them an application because they're looking for people. Right now, we're just 43 minutes away from the launch of this vehicle. Currently, they're fueling up. So
We often get asked,
stay tuned.
what is Relativity Space? Well, let me tell you, we are a rocket company. We build rockets designed to offer high performance and reliability while costing less to build and fly. This lets us put our customers first. Our long-term vision is to expand the possibilities for the human experience by creating humanity's industrial base on Mars. Our rockets, Taran 1 and Taran R, have already been met with significant market interest. To date, Relativity has announced nearly a dozen signed customers for commercial and U.S. government payloads. Some of our customers include OneWeb, Iridium, NASA, and the Defense Innovation Unit. Currently, Relativity's customer contracts amount to more than $1.65 billion. We are a
This
private
is
venture-backed
absolutely
company,
insane.
and to date, we have raised over $1.3 billion in capital with our most recent $650 million Series E round. This funding has allowed us to make progress on Taran R as well as get Taran 1 to today's launch. With that, let's take a step back and see how we're tracking towards launch.
We are currently at T-minus 42 minutes. The vehicle still appears to be operating nominally. The weather is looking good so far. We're still keeping an eye on those upper level winds, but other than that, we're tracking well towards a 1300 Eastern Time launch.
That is great to hear. Good luck, have fun is the maiden launch of our 3D printed Terran 1 rocket. Terran 1 is an orbital class rocket, and of course, reaching orbit would be a total home run. But as we've mentioned before, we're just truly looking for some important base hits here today. Notably, a key objective for today's flight is largely about proving our hypothesis that 3D printing is a viable way to manufacture a rocket, and it can successfully withstand the pressures of flight. Through robust ground
That's really the
testing,
key test
we're
today
confident
is
that we have a real shot at
can
proving
the
just
3D
that.
printed aluminum actually
And
survive?
the more data that we collect from this first flight means that we'll have access to more insights. And this will give us the confidence that we're able to execute on Taran R. And it will help us solve all the hard problems that come with building a medium to heavy lift reusable rocket. As a business, we are following the Pathfinder product development approach. So the Taran 1 that you see on the pad today has always been our Pathfinder. It was designed to be a development platform for Taran R, and it has served us
For a vehicle this
exceedingly
big to
well
be a
date in that
Pathfinder is
capacity
pretty crazy
as we
too.
progress through printing and testing ahead of today's launch. Arwa, what would we call success for today's launch?
Well, again, safely clearing the pad, getting out over the ocean, and passing the point of maximum dynamic pressure, or max Q, would be a big inflection point for today's launch. This is because it's the point where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight. This is the point in flight where we want to prove much of what has already been proven on the ground. During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter during flight, so passing this milestone would effectively demonstrate that 3D printed rockets are structurally viable. If we make it even further to stage separation, we will have achieved a full first stage flight, and that'll be another big accomplishment for the team. From there, we'll attempt to light the second stage and get Taran 1 to orbit.
So at that point, it's going to be so tough not to jump out of our seats if we get to that point. Just as a reminder, Stage 2 is targeting a 200 kilometer by 210 kilometer orbit, which is not a traditional orbital target. However, that is our target for today.
It's super
given that
low.
This is
It's a
our
super
first
low
launch
orbit.
and not a customer mission. There is no customer payload on this flight. Instead, to celebrate how far we've come, we have mounted our first ever metal 3D print from the first generation Stargate printer inside of Terran 1's nose cone. And while we're on the topic of setting expectations, we will also note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings. And as a result, the video connection could be spotty. So in the event that we do lose video, we will do our best to keep you up to date as we receive telemetry.
And I just want to update here that our launch time is set now for 13:45 Eastern. We have updated that with the range, and you can follow along on the time clock on the top left-hand corner. We do have strict safety protocols in effect for today's flight and are closely coordinating with the FAA and Space Launch Delta 45. These protocols are standard for all launches and ensure that no one would be in harm's way if there were to be an anomaly. The window for today's launch attempt opened at 1300 Eastern, and it lasts for 3 hours. The pad was cleared of all personnel again at T-minus 4 hours, followed by the start of propellant loading. Propellant loading is now nearly complete, and we're going to top off our tanks and condition our propellant shortly. At approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal
That's
flight
the point we
computer
made it to
takes
last time.
control of the countdown.
Was just the terminal
Now,
count.
while we wait for T0, let's talk about the process that got us here once again. Terran 1 is 85% 3D printed by mass. The items that aren't 3D printed include rubber seals, computer chips, valves, and other similar items. We see 3D printing as an automation technology, and we believe that long-term 3D printing will rapidly democratize space. We've already been able to unlock rapid part count reduction and rapid design iteration, and we're still very much in the early days of what's achievable. Now, we use 2 classes of printers here, powder bed fusion, or PBF, and vertical wire arc additive manufacturing, or Wham.
For those of you that are tuning in today for the first time,
Wham is the Stargate printer. That's the one that has the robotic arm and has the spinning bed that we showed before. And that's the one that they're using basically to build the entire rocket. It's also the one that is their unique technology that they're using to build these rocket parts. These smaller ones that you're seeing on the table are just built with a standard metal printer where you just lay down a layer of dust and then use a laser to put it all together.
second stage for Terran 1. We have been able to increase reliability through lowering our part count with PBF.
And now let's maybe pull up an example of one of our Wham development articles. Our proprietary Stargate printers use Wham for printing the vehicle's structure. We developed a proprietary metal alloy that begins in a wire spool and is then fed into a Stargate printer. It's then heated and cooled rapidly to form small beads that, in succession, create the vehicle structure, layer by layer. That includes the Stage 1 and Stage 2 tanks that hold the propellant, their internal ribs, the common domes, and of course, the nose cone. This is essentially what makes up the bulk of the visible part of the vehicle on the pad, except now it's painted white instead of the native silver that you see here.
So basically, this is what's making the entire structure of the vehicle, and that's why it's nearly 85% 3D printed. Is because they can use this 3D printing style to, 3D print a bunch of segments and basically bolt those all together to make a giant vehicle.
That is right. We have to launch Terran 1 today. So for those of you that missed Wednesday's broadcast, let's do a refresher about the Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall with a 7.5 foot diameter. Starting from the left-hand side and the bottom of the vehicle, there are 9 Aeon 1 engines. Each of these engines has a thrust capability of about 23,000 pounds at sea level. This gives us a max total liftoff of over 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle. We have thrust vector control actuators, or TVCAs, on the engines to gimbal the engines during flight. We have completed more than 2,000 engine hot fires, and with 10,000 seconds of runtime across the 191 Aeon 1 hot fire tests. The 9 Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the loads from the engine thrust. And above the thrust structure is the stage with the Wham printed tanks that Arwa just shared about. This holds liquid oxygen on the top tank and liquid natural gas on the bottom tank. These tanks are pressurized using an autogenous pressurization system. We tap off a portion of the propellant from the engine, and this is run through heat exchangers that are mounted on the engines. The liquid propellant is converted into a gaseous state, and then this is piped back into the top of the tanks to maintain our required tank pressures. Above stage
This is
1
actually a really
is
good
the
way.
Wham printed interstage.
So that autogenous pressurization is actually a really good way to maintain your tank pressure without using external pressurants. And it's actually exactly the same method that ASTRA is going to be using in order to keep our nitrous oxide tank pressurized. So it's also using autogenous pressurization. We're not going to like steal some propellant from the nozzle itself, kind of the way they're doing it, but in function, they're basically a similar methodology.
The fairing and also have a fairing separation system. As we mentioned, there is no customer payload for today since this is our first launch, but we did design Terran 1 with a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to sun synchronous orbit, or SSO, for customer missions. All data from Taran 1 development will be fed into Taran R. But our Taran 1 rocket is only part of the formula. As we get closer to liftoff, Arwa, how about another status update?
Yeah, of course. We are now at T-minus 31 minutes and counting. We're not tracking any current weather violations. As I said earlier, we're still going to keep an eye on those upper level winds, but the range is still green and the vehicle systems are still nominal. So as of now, we're still a go for our scheduled launch time.
So those upper level winds are kind of an issue because basically commercial vehicles, because they don't have a super high thrust to weight ratio like compared to an amateur launch, they're not going like super fast when they hit the upper atmosphere. And by upper atmosphere, I mean above 10 kilometers. Usually that's about the time when they're going through the transonic regime, which means they're just passing the speed of sound. And at those upper levels, those upper level winds can be going up to like 100 kilometers per hour, or sometimes even much faster. So the transverse velocity of the wind is actually a significant portion of the vehicle's actual velocity. So if your thrust gimbaling system on the engine can't like turn the engine enough to compensate against that wind load, you can really end up damaging your structure and putting way more strain on the structure than it's supposed to have. And then, of course, the structure could fail. So usually, rocket companies will always keep an eye on the weather to make sure that those upper level winds don't exceed the actual levels which the vehicle can take. So yeah, if there's a weather issue today, it'll probably be because of that.
Different levels under the rocket. The largest and lowest level is the pad deck, and directly above it is the launch table. This is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the...
Right now we're looking at the bottom of the launch vehicle where it's basically sitting on the pad, and there's basically a whole system there to divert the flame of the exhaust as it comes out at the start so you don't damage everything.
That provide propellant and other commodities to the vehicle while it's on the ground. And once again, a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare for today's second attempt. So thank you all so much for your incredible work.
So right now you can see that the vehicle is still being filled. So basically those exhaust plumes that are coming off of the vehicle itself are actually just liquid oxygen that is being vaporized, and because it's vaporizing and getting hotter inside of the tank, it needs to be let go, otherwise you could have an over pressurization. So it's constantly venting liquid oxygen, or sorry, vaporous oxygen, in order to keep the tanks at the correct pressure. Now that means that as you do that, you have to also add liquid oxidizer back into the tank. So it's like a constant process where you just keep the tank full by continuing to add a little bit of liquid oxygen and vent off a little bit of gaseous oxygen. And as long as that process is happening, you can tell that the vehicle is still, in a configuration where it's getting ready to launch. So if that stops for any reason, then you'll know that they're probably scrubbing for the day. But in the meantime, we're coming pretty close, getting a little bit closer here to their go, no go pull. It's going to be coming up at around T-20 to T-15 minutes. So if everything is all good at that point, then we'll be a little bit better of a more confident place where we can say that this vehicle will probably launch. But before we go any further, I just want to kind of cover a little bit of more information on the Taran R that they keep referring to. So this Taran R vehicle, which is not the one that's on the pad right now. The one that's on the pad right now is called the Taran 1, which is kind of their first rocket and their demonstrator program, what they're calling their Pathfinder program. But what they actually hope to build in the future is called the Taran R. And that's basically this guy right here. So the Taran 1 is there on the left, and the Taran R is this big giant launch vehicle on the right. And they've basically tooled their entire facility to be able to handle actually printing this bigger rocket. Here you can see them using that Stargate printer to print the base of the tank for the first parts for the Taran R. The idea of the Taran R is that it's going to be able to be fully reusable. So they'll be able to land that first stage back on the ground, kind of like a Falcon 9. And they'll also be able to land the second stage, the upper part of the vehicle. They'll be able to land that on the ground as well, kind of in the similar fashion as the Starship does. So that's like the ultimate vision they have, to have a 3D printed rocket that's completely reusable. Which, by the way, if they're able to pull this off, would totally revolutionize space transport. Because, I mean, if you can print things super quickly, like this printer can, but also you're reusing everything, getting to orbit is going to be way, way easier. Yeah, so this could be the future, and this is kind of the future that they're trying to build towards. So when we talk about the success of the Taran 1, this is kind of where this could be leading in the future. So something to get a little bit excited about, I would say. Anyways, this is the launch control right now. You can see it there. This is where they're going to be conducting the go, no go pull. So we'll be listening in to what they have to say very shortly here to see if this is actually going to be a go for launch today. And again, the key thing to look out for is the weather. It seems to be the one that could be the problem. Last time they had issues with the valve on their liquid oxygen tank. There were some issues with it maintaining the temperature in the tank. That mainly has to do with how they vent the liquid oxygen to the environment. So if they're not venting at the correct rate, then the temperature in the tank can climb or fall appropriately. So they kind of have to make sure that's working properly. So apparently this was a quick fix, and they were able to fix that within 24 hours. So now they're back on the pad with that problem hopefully gone, and we can look forward to a potential launch here.
If you're just tuning in, we are now awaiting a situational briefing from Clay Walker at around T-24 minutes.
I'm not sure if this is the go, no go pull. It might be just a milestone that comes right before that. This is the point where they stopped the clock the first time in the last launch attempt on Wednesday. So this is a critical milestone. It's always a bit stressful to be in the room while this is going on because, there's a lot of responsibility that's on the table. You have to make sure that each system is actually ready to go before you proceed to the next step. But yeah, if you guys have any questions, feel free to leave them in the chat. I'm happy to always answer any questions you have about either Relativity's vehicles, the Taran 1 or the Taran R, but also about ASTRA's vehicles. We are, of course, a student group, and we're trying to launch a rocket which will go to space. This is a common milestone for a lot of student groups. But yeah, we are in the depths of building and testing our own rocket, so we got a lot of the same feelings as these people at Relativity probably have right now. Yeah, I'm pretty optimistic that they are going to get this launch today. Getting the launch right on the first attempt is always a bit tricky, so it's kind of to be expected that it would take them, you know, until the second attempt to iron out all the details and get this vehicle ready to launch.
I'm hearing here that the team is looking into those upper level wins before we proceed with the situational briefing. We should have an update here in just a few minutes.
It'd be really unfortunate if the weather screws us over here. Yeah, but those upper level winds are always a concern. Also, if you may have noticed, it's not just the white clouds that are coming off the vehicle that you're seeing in the frame sometimes. Like when they go back to the picture where they're showing like the whole vehicle on the stand, you'll notice that there's like a little flare tower where there's a bunch of fire coming out of. That is not, let's see, is it over? Am I covering it? The flare tower there is not actually like a problem. It's there. The fire is coming out because they're actually flaring off methane. Remember that liquid oxygen isn't the only cryogenic thing that's being loaded onto the vehicle. There's also cryogenic methane. So they also have to get rid of methane from the tank. But they can't just let the methane into the environment because that's like, you know, an environmental issue. Plus, potentially it could be an explosive issue. So they have to flare the methane, which means they have to actually ignite it so that, you know, the methane is all burned before it gets released to the atmosphere. But it looks like everything is good with the vehicle. It still is filling just as normal. There you can see that flare tower just on the lower right hand side. That's flaring methane. So that's basically conditioning the propellant while it's in the tank, but you're not releasing the gas itself to the environment. Yeah, so the regulations behind launching model rockets are relatively tight, I would say. Like if you want to launch to an altitude that's below 1 kilometer, it's usually fine as long as you go to a designated site where you can actually do that. However, if you want to actually do, you know, higher power rocket launches, then yeah, it's very hard to do in Germany. Basically, you have to like have a cooperation with the military in order to get something like that. So typically you have to go out of country. We're doing the drop test from the helicopter, actually not in Germany. We're going to the UK to do that. There's some launch sites there where we're actually able to get the opportunity to do that.
The LD. We're holding the clock at T-minus 20 minutes due to upper wind violations. Stand by for a new T0 time.
Okay, so it looks like we're going to get stopped by upper level winds.
And as you just heard from Clay, the team is going to hold at T-minus 20 minutes. We're going to continue evaluating those upper level winds and get a new T0.
Yeah, that's unfortunate. But upper level winds are, of course, a weather thing, so maybe they'll go away. They have a whole 3 hours to get to launch this vehicle, so they still have 2.5 hours left in their launch window. So they have an opportunity to, you know, delay a little bit until the winds cooperate. This is always an issue. But yeah, coming back to the you know, regulations of launching things in Germany. The reason why we're not doing our first launch in Germany is just because it's nearly impossible for us to get, you know, the certification and the cooperation with the correct German officials to launch a rocket of this magnitude in Germany. So instead, we're going to Portugal, hopefully, to be able to have the opportunity to launch our first rocket, which is just going to be one that goes to 3 kilometers. I know, in the US it's so much easier.
Those white clouds that you see coming out of the rocket are due to venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds when it's coming out.
Basically, that liquid oxygen is being stored at minus 180 degrees Celsius, I think. So it's like really, really cold. So as soon as the gaseous oxygen basically contacts the air, what happens is it causes all the water to condense out of the air, and that's what creates that vapor cloud. So the cloud itself is not actually the liquid oxygen, it's actually the water vapor that's condensing out of the air because of how cold the liquid oxygen is. But yeah, we're very familiar with how easy it is to launch things in the US and how difficult it is in the European Union. This is just a tricky thing that we have to deal with because of our location. But we're hoping that in the future, one of the things that we're trying to do as a European student launch community is we're trying to develop more opportunities for launching vehicles within the European community. We hope that like Euroc is not like the only chance that students in Europe have to launch rockets. So we're trying to get more launch sites open and cooperating with students in order to make these types of launches possible. And hopefully for prices that are reasonable. Because right now, some of those costs are a little bit outlandish. Yeah. One thing that the US is blessed with, though, is a lot of open land. Like the EU has lots of people everywhere. So it's tough to find an area where there's like not very many people where you can do things like launch a rocket. For places like that, you kind of have to go east. And for obvious political reasons, that's a bit of an issue right now. For those of you who just joined, we are currently here watching and getting ready to see the Relativity's Taran 1 launch. But unfortunately, we've been put into a hold at T-minus 20 minutes. The reason why we're in this hold is because of upper level winds. So basically, the winds at about 10 kilometers to 20 kilometers are too fast. And this can create a lot of structural problems for the rocket when it's flying up to space. The reason for that is that, you know, the difference between the velocity of the wind and the velocity of the vehicle at those locations is really not that much. So basically, it creates a really big like vector that fights against the vehicle's movement. So you need to have gimbaling range at the bottom of the engines in order to compensate for that. And there's only so much gimbal that an engine can have. And this is what creates the constraints as to whether they can actually fly through certain winds or not. Typically, this is the most major, you know, weather-related constraint that a rocket will have. So now we're just waiting on a new T0 time. I suspect that they'll probably delay for a little bit and kind of see if that wind dies down. It could be that that's the case, so this doesn't necessarily mean that there won't be a launch today. So stay tuned. Don't get disheartened. If you guys have any questions about what's going on today with the Relativity launch, or just questions in general about rocketry, or about any of ASTRA's activities, we are, of course, a student group who's trying to build rockets.
For those just joining us, we are at T-minus 20 right now, and we're actually holding the clock due to upper level winds. The team is currently evaluating this, and we'll provide an update as soon as they have it. However, the vehicle is healthy and the range is currently green, so as soon as those upper level winds slow down a little bit, we'll be able to provide another update.
So you may be wondering like what kind of evaluation they're doing when it comes to the weather. I mean, it kind of seems like, well, either the wind is good or it's not. There's actually a whole bunch of complicated weather data that comes to you, to the launch provider, basically, in order to determine whether this rocket can launch. So we learned a little bit about this while we did our drop test, which was back in December of last year. We basically flew a plane up and threw our nose cone out of the plane to test our recovery system. But basically, you get data for all of the layers of the atmosphere. So like every single, 1,000 feet in the atmosphere, you'll get some sort of wind value that tells you the direction and the strength of the wind. And then basically they will plot that, you can plot those wind values into your trajectory simulation to figure out whether it's within limits that your vehicle can tolerate. And because of, it's quite a complicated description of what's happening in the atmosphere. So sometimes it can take a little while to properly analyze as to whether something is nominal or not. The other part to it is that, how do they actually collect all of this data? Because, it's, to get wind data that's that precise for all the different levels of the atmosphere, basically what they have to do is they have to launch these weather balloons, which, as they fly up, they measure what all of those different wind values are as they fly up. And when you were dealing with rocket launches like this, they might send up like a couple of those balloons in a day in order to determine, all of these things. So there's actually quite a lot of analysis that happens on the back end to determine whether a rocket launch is possible when it comes to things like wind values and other weather phenomenon. I suspect it's probably going to take them another 10 or 15 minutes to figure this out. Hopefully they're still planning, this wind won't just scrub the whole launch. We have a beautiful day here. There's no clouds in the sky at all, completely blue sky. The tracking shots that we would get if it launches would be really fantastic, which is secretly why I want it to launch right now. There's nothing better than getting a launch on a completely blue sky. It's absolutely fantastic. So it's really too bad these upper level winds are not cooperating. It would be really nice if you could design a rocket that just didn't care about that. They could just handle those upper level winds, no problem. I wonder how sensitive Starship actually is to those things. Because they can really mess with your launch frequency if you if your vehicle's limited by weather like this. It doesn't seem like the Relativity team is giving up though, because you can still see those vapor clouds coming off the vehicle, which indicates that they are still continuing to fill the rocket with liquid oxygen and vent that liquid oxygen or gaseous oxygen in order to maintain the pressures in the tank. So that's all very positive. One thing that's interesting about the tanks themselves, the main stages propellant tanks, is that they, instead of being pressurized by an external pressurant like helium, for example, the Falcon 9 first stage propellant tanks are actually pressurized by helium, which is stored inside of a CFRP bottle inside of the tank itself. This Terran 1 tank is actually not using any helium at all. So it doesn't use an external gas in order to pressurize the tank so that you can feed the pumps that are down near the rocket engines. Instead, what it's doing is it's actually taking some of the liquid oxygen and liquid hydrogen that get fed near the engines. So they get fed near the combustion chamber and they heat up a lot. They tap off a little bit of that gas and they pipe them back into the tanks themselves in order to pressurize the tank. So basically they're using the heat of the engines themselves in order to continue to keep the tanks pressurized. And this is actually a really clever way to save on system complexity and also save a little bit of mass, because you don't have to carry that like extra helium tank all the way with you. Trying to use a similar method to that in order to actually make our rocket Transcendence fly. So we're using what's also the same technique, autogeneous pressurization. We're not going to take some of the nitrous oxide that goes to the engine and like pipe it back into the nitrous oxide bottle. Instead, we're just going to use the properties of nitrous oxide, which is stored at 55 bar, in order to take advantage of the fact that some of it will boil off and continue to pressurize the tank. In this case, ours is completely pressure fed, so there's no like pumps or anything. But it just goes to show you that, you know, similar techniques that are used in the commercial industry can be applied to the amateur rocket settings as well. So there's a lot to learn from these types of vehicles and how they solve their engineering problems. But for now, we're still in this hold at T minus 20 minutes. And the reason why we're here is because of those upper level winds. And you can see even on the ground, it looks a bit windy. Those palm trees are looking rather wind beaten. This is actually personally my favorite view of the vehicle with those two palm trees. This camera is probably like 5 kilometers away or something. Just to remind you, this launch is actually taking place in Florida. So it's it's basically on the on Slick 16, which is one of the launch pads that are available at the Kennedy Space Center. It is actually an older pad, so was used a lot back in the 70s and the 80s, but it kind of wasn't used for a very long time, and then Relativity was able to get the space and renovate it so that they can launch their vehicles on this pad. So yeah, there's actually a lot of vehicles that are going to be launching out of Florida these days. So it's turning into a busy spaceport. It almost seems like there's a rocket that is launching on a daily basis, especially with SpaceX always there. If you guys have any questions about the rockets or about ASTRA, please feel free to leave them in the comments, because I'm happy to talk, especially while we're just waiting here. There's not much to do in the meantime. This is a cool view of the engine. Here you can see these are the Eon engines, and you can kind of see they have this like weird insulation that goes all the way around them. It's unclear as to what that's actually for. I haven't been able to figure this out yet, but it seems like maybe it's like a thermal insulation, but it could also be like a sound thing. I'm not sure. But I've never seen this type of like insulation over top of engines before, especially like on the first stage. It's kind of weird. If you have any ideas what it might be, please let me know. These are the engines that have that are running on the methane and the oxygen, and it's the only engine that Relativity makes right now. They basically have 9 of those on the bottom, and then they have 1, or is it 7 on the bottom? It might just be 7 on the bottom. I could be crazy. And then they have 1 that's on the upper stage, but it's optimized for vacuum. Yeah. The way they optimize engines for vacuum, because like it's basically the same engine, the Eon engine that's on the bottom as is in the upper stage. But the difference is that the one on the upper stage is actually having a much wider nozzle. And the reason why they do that is because the wider your nozzle is, the lower the pressure of the gas that is leaving your engine, and the faster that the gases will be going, which means that you get a little bit more efficiency. In space, that's possible because the outside pressure is very low, so you can basically have a wider nozzle which goes to a lower pressure, and you can get that extra speed on the gas particles. But the problem is that if you use that near the ground where the pressure is much higher, basically the pressure of the atmosphere would push in on the nozzle and would push into the nozzle and create a bunch of instabilities, which would cause the nozzle basically to break apart structurally. So you kind of have to have smaller areas of a nozzle when you're on the ground in order to make sure that the pressure of the propellant that's coming out of the nozzle is enough to push against the atmosphere. Steals a little bit of efficiency, but that's the consequence of trying to use a rocket engine with atmosphere around you.
For those just tuning in, we did hold the clock at T-minus 20 minutes today, but we're expecting a briefing in the next 5 to 10 minutes on what's happening with the upper level winds that were the reason for us holding the clock. We'll continue listening in and hopefully everything sounds good.
So it looks like we're going to get an update here pretty soon on those winds. I suspect they're probably just going to try to push the launch a little bit to a place where the winds might be a little bit better. They have to do a little bit of prediction here as well. It's not just looking at the data. So I was talking before about how they, send balloons up and they collect data for the winds at all these different levels. And they also go and feed that into a system where they look at their trajectory and see, okay, is our trajectory still okay considering winds of this magnitude here, and all the way up through the wind column. They're also doing a stress calculation there too, because they're looking at the stress on the vehicle at each of those places to see if, okay, is the stress okay at this level? Is it okay at this level? And they can basically figure out, with all this data, are we good to launch? But they also have to do a little bit of prediction. So they want to actually predict when the winds will be in a certain way. So there's a little bit of forecasting that happens here as well. And that's where like the weather guys come in and they do their, forecasting magic to see if they can figure out if it might be better at a different time. So that's kind of what's happening here too. Hey there, Xerxes. Yeah, are we using a machined graphite nozzle or messing around with phenolic stuffs? I really don't like messing around with phenolic stuffs, so we're not doing that. Instead, we're gonna, we've machined a graphite nozzle. We actually just received this nozzle last week. Yeah, it was last week. So we're happy to finally have our first nozzle completed. It looks beautiful. Unfortunately, I don't have any pictures right now. I'd love to show you. It'll be featured in a video that comes onto our channel, I'm sure, in the next couple of weeks. We had to go to the commercial market to get this graphite nozzle because we don't currently own a lathe, so we couldn't make one ourselves, unfortunately. This is a problem we're trying to solve soon because, of course, it's very difficult to continue to run a rocket program without having as simple of a tool as a lathe. But yeah, right now we're just using a machined graphite nozzle. I think that's probably the simplest way for us to wrap our heads around trying to design a rocket. One thing that we are considering though for the future is trying to switch to 3D printing metal. So this is where relativity comes in again. We've taken some inspiration from the commercial market. It turns out that you can actually save a lot of mass if you potentially switch to a 3D printed nozzle, because you can 3D print with metal like stainless steel, And then you can just in the spots of the nozzle that get the hottest, like right at the throat, you can just throw in a little bit of a graphite insert, and then basically you can just use that as your nozzle, and you save all that mass of a much bigger graphite structure. Because of course you can make the stainless steel a lot thinner, so you can save mass. But that's more for the future. That's if we can figure out if we can get a 3D metal printing. If we can get a sponsor that allows us to do 3D printed metal, then of course we would start going down that path. But for now, we're happy with our first graphite nozzle. So we should be coming up here pretty quickly on the update that they claimed they were going to give to us about these upper level winds. Their analysis should be complete relatively soon. I'm hoping that they find a window where they think there might be better winds. Again, they do have a 3-hour launch window, which started 45 minutes ago. So they have 2 more hours in that launch window, just over 2 more hours. So that's kind of a lot of space where they might be able to find a slot where they can get some better weather. Still seems kind of weird that we're looking for nicer weather and it's like a gorgeous day with blue skies in Florida. Like, how much better does it get? But rockets are temperamental. They have other concerns than our standard human concerns. Yeah, it was also snowing here in Germany. We woke up this morning to about a couple inches of snow, which is like super weird because it doesn't really snow like that in Bremen typically. I come from Canada, so that's more normal for Canada, but in Bremen it was a bit odd. But yeah, it was snowing here too. Oddly enough, snow is not really a problem for rockets typically. So I don't think this rocket would mind if it was snowing. Snow is bad for the space shuttle. That created some issues for its O-rings and stuff. It was 15 degrees yesterday for you. I don't think I felt 15 degrees yesterday. It started to snow last night for us, so it was still pretty cold. Ah, the northeastern Czech Republic. Yeah, you probably get some better, more warmer weather there than you get in Bremen. The thing with Bremen is that you're right beside the North Sea, and that typically cools things down in general. It's a very cold part of the ocean. But it's kind of nice for the summer because it doesn't get too hot in the summer. Like, it's very weird if the temperature ever goes above 30. Yeah, you're right. No clouds typically does mean that there's more higher altitude winds. So that's kind of a weird thing. You think that blue skies, like for amateurs, if you have blue skies, that's like, it's a great launch day. But for a commercial rocket, it's not necessarily the best. It's better to have some light cloud coverage, usually, because that indicates that the upper level winds are better.
For those just tuning in, we once again held the clock at T-minus 20 minutes Due to weather issues, unfortunately, upper level winds are currently marginal, so the team is evaluating live data to determine if we can go ahead and keep rolling the clock or if we need to pause for a little bit longer.
And as we wait on that additional data on the upper level winds and as we get an update from the team, let's go ahead and take a moment to get an idea about all the work that the integrated performance team does for Relativity Space.
So yeah, here we go.
Integrated performance at Relativity.
I'm a vehicle simulation engineer.
And I'm a staff vehicle simulation engineer.
One of the key things that we focus on in the department is connecting all the different teams, making sure the structures work with the engines work with the software, and the software works with the electronics hardware. I was lucky enough to work in a few different hardware.
So yeah, we're still waiting on an update on whether we're potentially going to get a launch date today. We're still holding at the T-minus 20. Although I suspect if they do get a good wind time slot somewhere, they'll probably cycle back the clock a little bit. For now, though, what they're doing is they're basically analyzing a bunch of data for the weather. So there's a whole bunch of weather balloons that they send up into the atmosphere, and basically these balloons are calculating what the wind levels are at every single altitude. And then they can use that data to do a little bit of forecasting as to what they expect the winds to be in the future. So I assume that what they're doing is they're analyzing that and trying to determine what are the probabilities that they're going to be able to get upper level winds that are within the constraints of their launch. And I expect they're also operating in an abundance of caution right now because this is the first launch, and they're really trying to use this launch as a demonstrator of their 3D printed technology. So the worst thing for them would be for this vehicle to fail structurally because of wind. That would not be a very good start to the whole 3D printed rockets are great. So I expect they'll probably take their time with this and not gamble with the structural integrity of the rocket. Yeah, we'll see how that goes. They were telling us an expected update would come soon, but I think soon has come and gone. So I'm getting a little bit less optimistic about whether they're going to launch today. It's really too bad that such a beautiful day on the ground does not equal such a beautiful day for rockets in this case. Yeah. It looks like the clock was just moved back to 40 minutes. This is probably an indication that they've selected a slot where they can potentially launch the rocket, because it was at 20 minutes before. So I think this could be a good sign. Of course, that will only be the case if they start to roll the clock. We'll see. In the meantime, if you guys have any questions about the Terran 1 or the 3D printing that they're doing there, or any questions about ASTRA, please feel free to leave them in the comments. I'm of course here as the chief engineer of the ASTRA team, so I'm always happy to talk about rockets, talk about ASTRA, talk about our vehicle transcendence, or whatever else. Right now we can see that the vehicle is still on the pad. It's still getting fueled up because we still see those vapor clouds coming off the vehicle. It's looking a bit windy on the ground even.
It looks like we are coordinating a new T0 right now that is going to be at 14:35 Eastern. We're awaiting confirmation from Mission Control at the moment.
So that's in
we're
40
continue
minutes.
Listening into them for any further updates.
So 14:35 Eastern is in 40 minutes for those not living in the eastern United States. But they still haven't started the clock, so that's not confirmed yet as being the new T0. So just stay tuned for the update that's probably coming quite quickly. But yeah, as I was saying, everything is still looking good. They're still filling the liquid oxygen into the tank. They mentioned a really interesting thing at the start of the stream, which has to do with their propellant conditioning. Okay, it looks like they just walked back the clock to 38:20, so I think they're probably going to go for that 14:35 launch time. This is good news. But yeah, like I was saying, just one thing to say about the propellant conditioning that's actually quite interesting, which is that because they're using methane as their fuel, they actually have an issue when they're cycling the methane through the tank in order to keep it cold. Because as they do this, they're basically piping in methane plus a little bit of other particulates, because they also have some butane and propane that are kind of mixed into the methane a little bit, just like very fractional amounts. But what happens is, as they put that into the tank, some of it will boil off, but the only part that boils off is the methane. So essentially, as time goes by, the tank slowly becomes more and more comprised of the butane and the propane, which is like not good for the engines. So after a certain period of time, they essentially have to completely detank, and they can't use that fuel anymore because it's too little of it is methane at that point.
All right, and now the T-clock is rolling again. We are now 38 minutes away from our new scheduled launch time of 14:35 Eastern. Again, that's 14:35 Eastern, less than 40 minutes away.
So this is good to see. We are now back on track. It looks like they found a window of time where they could hopefully have some better winds in the upper atmosphere. So that's good to see. Hopefully all the technical things are also still working okay. And hopefully the methane issue I was talking about there has not gotten to the point where that's going to start creating issues. But yeah, essentially what happens is the rocket essentially becomes like a refinery. So by them just boiling off the methane, they're essentially refining this solution that they have to make it more and more and more butane and propane. So they're like making propane and butane, which is kind of a weird effect that happens when they do this. I never really thought about that problem when considering a methane system before. So for those of you just joining, we're now sitting at T-minus 36 minutes. We had a hold for the last hour or so, or maybe not quite an hour, it was only like 40 minutes, because the upper level winds were not good. That means that the winds that are at like 10 kilometers in altitude or so were too strong for the vehicle. So now they basically went over and did some analysis with the wind data that they have, and they found a period of time, which is now in 36 minutes, where they think the winds in the upper atmosphere will be much better. And now they've restarted the clock, and we're counting down again, now at T-minus 35. The closest we've gotten so far is T-minus 20 minutes. So let's see if this round gets us a bit closer towards that launch time. And if you remember back to 3 days ago, they also tried to launch the rocket then. You'll remember that they cycled down all the way to T-minus 70 seconds. So they got quite close to launch. But at that point, their automated abort system kicked in because of some issues they had with the oxygen tank. It was out of temperature range they want to launch. In this case, it was an issue with their oxidizer, their oxygen valve. They've switched out that problem. They fixed it up. So that should not be an issue today. Yeah, I'm hoping it launches as well. I'm hoping it launches. But, you know, don't get too disappointed if it potentially doesn't, because again, this is a test vehicle. So they're still figuring out their system as much as we're trying to figure out their system as well. A little reminder for those joining just now as well. This is a rocket which is printed entirely out of sorry, it's a completely 3D printed rocket, and they've 3D printed it not out of plastic. It's actually 3D printed out of aluminum, and it's, I believe, the biggest 3D printed structure in the world. There's no bigger 3D printed structure in the world than this rocket that you're seeing on the pad right there. It stands at about 35 meters tall, which is just over 100 feet tall. To put that in perspective, that's about like just under half the length of a football field. So it's quite a large vehicle. It would definitely be a lot taller than your house. And it's all completely 3D printed. And they use these, what's called the Stargate printer. And it's basically this giant like machine. And it's operates kind of like a normal 3D printer. It just lays down aluminum layer by layer by layer, and they build up these like giant pieces of the tanks, which they then put together to make the whole entire launch vehicle. So yeah, this is kind of the, I don't know, the new way of doing rockets, and they're trying to prove that this is actually a way that you can build a rocket with this Terran 1. It's their Pathfinder launch vehicle. They have lots of big plans for the future, and if this one can work properly, then they'll be quite happy. I'll also be quite happy. There's a ton of applications that you could do with a 3D printer like this. Because it can like 3D print metal, aluminum, you can like think of all the things you could 3D print like on Earth, number one, but also if you could send one of these like to space, to the moon or to Mars, or even just into orbit, like think of the structures you could create. Yeah, whether the 3D printing is actually cheaper for rockets is a bit questionable, I would say. It's certainly better for prototyping because you can like easily like print a new one that's slightly different, that fixes the one problem that you had in a test or something. But when you're dealing with like lots and lots of vehicles, sometimes like a factory kind of setup is maybe more efficient, because like a 3D printer is like constantly like melting everything together, so it like uses a lot of energy. At least that's my experience with 3D printing anyway. Sometimes there's like some cheaper ways to do it. But that being said, when you are on the moon or on Mars or in space, like there's no factories, there's no special tools, there's no machine shop down the road that you can just go get a part machined at. Like you have nothing. So if you can bring a tool which can basically take resources from the environment and just print, that's huge.
We're now at T-minus 31 minutes, and you might be wondering where we built the launch vehicle that you're seeing on the pad. We currently have 2 manufacturing facilities in Long Beach, California.
Here you're going to see those
today's
3D
rocket
printers.
was printed at our second factory called the Portal, while our new headquarters, named the Wormhole, is home to our 4th generation Stargate printers. This is the 1 million square foot facility we are currently expanding into that will serve as the epicenter for Taran R development and production.
Speaking of Taran R, Terran 1 is truly a pathfinder to that vehicle. The real
One thing that I will say is, like you mentioned there, that you won't survive the re-entry heating. Well, actually, like they just mentioned with this vehicle called the Taran R, they're trying to completely reuse that vehicle. So their plan is actually to use this 3D printed aluminum and use it as a foundational structure, which will be for a completely reusable vehicle. I assume they're going to put some like shielding on that or something, but I mean, for now, we don't really know what their plans are for that. Here you can see their engine testing. This is their Eon engine right now that you're looking at, which is basically what's going to be powering their vehicle. No need to worry about the liquid aluminum actually raining on you. If it does burn up in the atmosphere, it would basically vaporize. I'm not sure it would ever rain out. It would kind of like stay in the upper atmosphere.
of the Aeon R thrust chamber assembly. I want to give a special shout out to Jake Shearman, Senior Manager of Combustion Devices, the Propulsion Test Team, and the Stennis test teams for accomplishing that critical milestone. So full power means 258,000 pounds of thrust at sea level. That is what we are designing Aeon R engine to. And that is 10 times the capability of the Aeon 1 engine that we have on Terran 1 today.
So they're already testing and designing their next generation engine for the Taran R. Like, this is like they're doing it right now.
Full-scale thrust chamber assembly. We are currently building our integrated engines, and on our Twitter feed, you can actually see an image of our first integrated engine next to a human for perspective on size. We are also completing building of our turbopump assembly, and we're planning to go into full engine tests throughout 2023.
And we're going to test those engines over at the NASA Stennis Space Center in Mississippi, where most of our testing is done. In 2018, we secured the first Commercial Space Launch Act, or CSLA, agreement with NASA Stennis, and we now occupy several operational.
So just to answer a question that came back there a little bit, are we planning to do injector testing in 23? Well, we actually are building our injector right now. We're going to be going to the lab on Monday to drill our shower head injector. That's going to be our first attempt at an injector, and we're basically going to test that in the first part of our propulsion testing that we're doing in May. So that's when we're going to know if our injector is actually working the way we expect it to. But yeah, fingers crossed for that. This is one area of the rocket that we don't really have a whole lot of internal knowledge in the team, so it's definitely probably one of the more difficult problems that we're trying to solve.
Cape, but we've also acquired a site in Vandenberg, California, as an additional option for future launches. In 2019, we secured a direct agreement from the U.S. Space Force for Launch Complex 16.
So they're going to be launching in
Relativity
California
joins
soon.
Just a few others
if they
here
have
as only the fourth
a spot at
company
Vandenberg.
with a currently operational orbital launch site at Cape Canaveral. Both Terran 1 and Taran R will launch from Launch Complex 16. With that, we are now approximately 27 minutes away from launch.
This is so exciting.
We're getting closer.
Continue to move forward, but just as a reminder, we do not have a customer payload on board, but we do have a memento in the nose cone. We have included our first ever 3D printed piece from our Stargate printer. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you see there is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece.
I wonder what it was for.
GLHF for good luck, have fun, and our mitosis logo to commemorate this maiden launch.
And from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. Like the first print, Terran 1
also
is
the
first
biggest
step
3D
of
printed
many
structure.
towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Taran R, our larger medium to heavy lift reusable launch vehicle. Now we're currently at T-minus 25 minutes. We're going to continue standing by for further updates from Mission Control.
So we're going to be getting, we're probably going to be getting an update around T-minus 20 or so with regards to their readiness. How did that 15 degrees tilt work for that hybrid that you were testing with? I'm curious. Right now, our shower head is just going straight down, so there's not much direction towards the center. Our grain, like the actual propulsion grain, is kind of like very thin on the outside for our first subscale vehicle. So we're thinking that potentially directing all of it to the center is probably not the best methodology. But another idea we're playing around with was actually trying to do a bit of a swirl injector by angling the holes and kind of having them swirl around the combustion chamber. This is one method that a lot of other student groups are kind of playing around with. So we were thinking that maybe if we did that, we could enhance our combustion efficiency. But all of this is, of course, theoretical until we actually get to the launch stand. So, sorry, the test stand, which will be coming in a couple of months here. So we'll have much better information at that point. But yeah, a pintle injector is definitely a challenge. That's like next level. First, we're just trying to get the shower head working. For those just joining, we are on the launch pad right now. That was a pretty big gas cloud that just came off. We're only 23 minutes away from the launch of the Taran 1, which is Relativity Space's new vehicle, which we're hoping will be able to get to orbit. The cool thing about it is it's entirely 3D printed. So this is going to be a demonstration of that technology and whether it will actually be effective for a launch vehicle.
All parties on net. Situational briefing for go no-go. All parties be aware the go no-go poll will be performed in approximately 10 minutes. Primary test objective is a transition into countdown through terminal startup and release into flight.
So T-minus 15 minutes or so.
Propellant is loaded. We are tracking no additional items for constraints. And while we are still waiting on one final balloon, we are still a go unless that balloon comes back as negative.
So
all assets are standing by for launch. We will do polls in approximately 6 minutes. Stand by all parties.
That balloon he mentioned is just waiting on the upper level winds, so it's probably up there measuring what those winds are. So it's going to be the final confirmation as to whether
and you just
this
heard
is actually a go.
that situational briefing from Clay Walker. The vehicle is very healthy right now, and the only issue that we're tracking is unfortunately the weather. But we are awaiting data, the latest data from our weather balloon to determine if we can continue and go ahead with our scheduled launch time of 14:35 Eastern.
So we're still tracking towards the same target T-0.
As we continue to wait, maybe let's do a recap on the Terran 1 architecture and go ahead and look at this graphic of our Terran 1 architecture.
Here you can
As
see
a
there
reminder, Terran 1 is
what it looks like.
110 feet tall and 7.5 feet in diameter. We have 2 stages that are expendable. On the bottom, we have 9 Aeon 1 engines. Each has a thrust capability of about 23,000 pounds at sea level, giving us a max total liftoff of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and as you previously heard, we have thrust vector control actuators, or TVCAs, on the engines that allow us to gimbal during flight. We have completed more than 2,000 engine hot fires as we prepared going into launch today. The Aeon 1 engines are attached to the vehicle through a thrust structure, and above the thrust structure we have Wham printed tanks. Arwa previously shared that this is the wire arc additive manufacturing in-house process that we use. And these tanks hold liquid oxygen on top and
That's
liquid
their
natural
special
gas on the
3D
bottom.
printer.
During flight, we pressurize our tanks using an autogenous pressurization system. This means that we tap some propellant from the engines, and this is run through heat exchangers mounted on those engines.
This is
and
similar
converts
to how
the liquid
ASTRA
propellant into
is
a
going to
gaseous
pressurize
state,
our tank.
and we pipe it back to the top to maintain the required tank pressure or ullage pressure. Above the stage 1 tanks, we have a Wham printed interstage, which holds our stage separation mechanisms. This is what we use to separate stage 2 from stage 1 during flight. The stage separation system uses pneumatic pushers. And above the interstage is stage 2, which has a single Aeon vacuum engine.
We just got past
this
20
engine
minutes.
has a thrust capability of more than 25,000 pounds in
This
vacuum
is a good sign.
and has the capability of multiple restarts. Stage 2 is also Wham printed just like stage 1. And above stage 2 is our Wham printed nose cone, which we just shared about the memento inside of that nose cone. For future missions, we will replace this nose cone with a fairing and also include a fairing separation system. Terran 1 was designed with a payload capacity of 1,250 kilograms to LEO or 900 kilograms to Sun Synchronous Orbit or SSO. All the data from today's launch and Terran 1 development will be fed into Taran R. But note that
RCS checkout's complete.
We're going to go ahead and pause and listen in on mission control for any more updates. Thank you.
So the RCS checkup, that has to do with the reaction control system. That's going to be what's stabilizing the second stage on its way to orbit. So obviously that has to work for this whole thing to work. But yeah, going back to the questions about injectors, yeah, oxidizer circulation in the upper section is certainly a concern for hybrids. But if you design your swirl injectors properly, it should be manageable. And technically, the swirl injection does give you better performance, at least according to the
As of now,
groups that have tried
it
it.
seems like everything is on track, and we're going to perform the go, no-go polls in just a few minutes here. So we're going to stand by to listen into mission control.
We expect that poll in about 3 to 5 minutes. Last time they did it at T-minus 15, so that would be the key spot. And this will be basically the, how shall I say, operational readiness point where they basically are saying, yeah, the vehicle is good to go. And I think they'll also make a final call about the upper level winds because they do have a balloon that's up there currently logging data. Although it does seem to be getting windier at the ground. So you can see from the trees there that it's getting a bit breezy. Yeah, we are a bit concerned that the shower head principle, although it's very simple to make, like we're literally just going to drill a bunch of holes into a steel plate, it's possible that we don't get enough atomization, but we're hoping it'll be enough. In the end, for our first vehicle, it doesn't need to be perfect. It just kind of needs to work. We're not looking for like ultimate efficiency. We're kind of looking for ease of manufacture and, you know, making sure that we actually know how to ignite a rocket and keep a rocket going for a full burn. So the simpler we can make it, the better. For those tuning in just now, we are getting close here to the go, no-go poll. So basically, they'll be making a determination as to whether the vehicle is going to be ready to go today. Just to remind you, we do have a launch window today for this Terran 1 vehicle. It can happen, the launch can happen from anywhere between I'm using my time, anywhere from 6 UTC to 9 UTC. So that window started about an hour and 20 minutes ago, which means they have an hour and 40 minutes left.
This is the go, no go for launch.
Okay, here we
Please
go.
provide concurrence to proceed into launch with launch countdown go, no go. BC. BC go. BC go. GC1. GC go. GC go. GC2.
GC2 go.
GC2 go. Ground. Ground go. Ground go. AVI. AVI go. AVI go. FTS.
FTS go.
FTS go. RF.
RF go.
RF is go. GNC. GNC go. GNC go. Flight software. Flight software go. Flight software's go. Prop 1.
Prop 1 go.
Prop 1's go. Prop 2. Prop 2 go. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 1's go. Fluids 2. Fluids 2 go. Loads. Loads go. Loads is go. Rock. Ranges go. Ranges go. OSM.
OSM is go.
OSM is go. RC.
RC go.
RC go. Vehicle.
Vehicle is go.
Vehicles go. CE.
CE's go.
C's go. LC.
LC is go.
LC is go. All parties have reported go for launch countdown.
So we're a full go.
Once the clock begins to roll, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or a manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify the LD and the RC on the primary net.
So just to remind you, if they...
And you just heard our launch director complete the go, no-go polling with our mission control team. As you
This is good
heard,
to hear.
all systems are currently healthy. So as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Now let's take a moment to introduce you to our Mission Control team. As you just heard, Clay Walker, Launch Director, John Wiswall, Launch Conductor.
So basically, the way the rules work at this point is at any point between now and T-minus 70 seconds, anyone can call a hold, which means that they will basically hold the clock. But they will still try to recycle the vehicle and try to go for another launch time. Remember, we have a launch window that goes from an hour and a half ago to an hour and a half from now. So it's a 3-hour launch window. So they can always recycle in the case of a hold that happens in that time frame. But if there's a hold that happens less than 70 seconds from the launch, so less than T-minus 70 seconds, then that puts the vehicle into an automatic abort. So basically, we're done for today, and we try again. Later.
Go ahead and take a moment to wait as we get more updates from Mission Control.
So we should hopefully not hear any more holds at this point, because that means that we're going the wrong direction in terms of launch. But we're getting there. We're getting there. Yeah, just one point to say towards the way we're designing our first rocket, which is that the key is that you want to design something that's actually manufacturable. So that's one of the key constraints for ASTRA.
You'll be able to see small white pieces falling off the rocket. Not to worry, that is just ice falling off from the frost on the vehicle due to the chilled propellant inside. On the other view, you might have also seen a small flame to the far left of the view, and that is just the flare stack that's used to burn off any flammable gases from propellant loading and venting operations.
So yeah, in terms of manufacturability, whenever you're an amateur, that's kind of like the key constraint is whether you can actually manufacture something. The beautiful thing about metal 3D printing, though, is that it really takes away that limitation in a lot of respects. So
once again, those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds.
With a metal 3D printer like the one that Relativity Space is working with, basically manufacturability kind of becomes less of a problem because you can pretty much print anything in any shape and any kind of design you want.
In just about 46 seconds here, we will begin our countdown sequence.
So we're nearing T-minus 10 minutes. This is a much closer to the launch than gets us a little closer to the actual launch and potentially the realization that this rocket will actually leave the pad today. If this was my rocket sitting on the pad, I would probably be a little less worried than I think the Relativity team is in terms of, vehicle health, because I have a 3D printer that I can just print a new one.
And we're currently at T-minus 9 minutes and 45 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, as you just heard, and we're currently proceeding with our scheduled launch time.
Everything's looking good so far. This is definitely looking good. I am getting a little more positive about a launch today. Let's hope that wind is not going to become a problem. That would really kind of ruin the show. So what are the probabilities for today? I think we are 60% launch, 40% scrub.
In just about 30 seconds, we'll be transitioning stage 1 to helium.
I'm not sure exactly what they're using that helium for, but I think it's to actually start up the engine. Get the pump spinning.
And I'm receiving an update here. We just got the data from our latest weather balloon, and we are a go with upper level winds. The weather isn't stopping us today.
This is fantastic. Hopefully that balloon doesn't give any more data.
Transition to helium.
And we stay a go.
And that means we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight,
for engine chill.
we'll pressurize the tanks with autogenous pressurization. That last call out was that we're pressurizing the tanks for engine chill.
Yeah, it sounds like they're pressurizing the LOX tank with helium, which is a bit... Okay, yeah, I bet you I know what's going on here. I think they use autogenous pressurization for the methane tank, but for the oxygen tank, because they're not taking the oxygen and running it through the cooling channels, they actually just pressurize that one with helium.
The business end of today's countdown. Let's take a moment to walk through the launch timeline.
At T-minus 3 minutes, the transporter erector, or that black truss structure, will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. Then at T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. And we then go into final flight termination checks
to igniters and flight targets.
And get FTS go from the launch conductor in coordination with the mission flight control officer and operations.
So we're not delayed today. Well, we were delayed a little bit by some higher level winds, but we're 6 minutes away from launch, so we could be in a very good situation here. So stick around. It might be worth your time.
We will have liftoff. Shortly after that, at T+2 seconds, the strong back will throw back to assist in removing the umbilical.
For those just joining, we are very close to launch, just 6 minutes away. So definitely stick around, because this could be the time we see this thing fly. We're just going over the sequence of the launch right now.
Again, where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine.
So for the Eon 1 engine, it is, I believe, a gas generator engine. That's what they were telling us in the live stream. I wasn't able to find a whole lot of data online about the Eon 1 engine besides just its capabilities. So we definitely need a little more information on what's actually going on underneath the hood for that one. But as far as I'm aware, it's a gas generator, which means that they're basically taking some of the fuel, putting it into a premix chamber, and they're using that to run the engine. And that extra, the propellant from that pre-combustion chamber is just getting thrown overboard. So it is essentially an open cycle. I'm pretty sure that we're not going to have any as many technical issues today, because they have worked through those last time. I'm assuming that we're probably going to have a higher probability of launch today. So here you can see there's actually like some gases coming out of the nozzle.
The igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across a glow plug.
There you go. They just explained it for you.
Stage 1 igniters priming in.
Exactly. So basically what they do is they have a little bit of the methane will basically go through the nozzle, and just some of it will be tapped off and sent back into the methane tank for pressurization. But the oxidizer tank is actually pressurized with helium, because obviously you wouldn't pipe back the methane into the oxidizer tank. That's obviously going to be like an explosion risk. So and they also don't take the liquid oxygen through the nozzle, so they can't just, you know, pipe back a little bit of that and continue to pressurize the oxidizer tank.
And you'll now see those cradle arms are slowly starting to release stage 2 at the top there so that the strong back can retract.
All right, guys, we're getting closer here. 3 minutes away. So that back is now just going to kind of move back a little bit.
Stage 1 TVC checkouts.
Over the next minute and a half, we'll be performing the final thrust vector control health checks on both stages before liftoff. You'll be able to see the engines gimbaling or tilting if we're in that engine view. There we go.
So we just saw the engines were kind of practicing to gimbal. You see that there?
Stage
That's
1 is on internal power.
Quite a good range of gimbal, I would say. It's kind of like the flight check before, just to make sure everything's all good.
And now that black truss structure behind the vehicle will retract just a few degrees to prepare for umbilical separation.
Just a couple minutes left here. So far everything is going as we expect. No issues.
Stage 2 TVC checkouts.
As we approach T-minus 2 minutes, what you're looking at on your screen is a vehicle that is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final range status.
So it might not be an open cycle. I was just making an assumption on that one. It could be that it's actually a closed cycle. But I'm kind of pretty sure it's an open one, because it's usually these, like, it's very unusual for a company to make a closed cycle gas generator. It's a bit more uncommon. You know, the nose cone doesn't actually have to be that pointy for a... Oh, shoot. Come on. There's a range problem.
Call out. Someone is calling a hold due to the range. We're going to stand by for updates.
This is so annoying. For the range? Who's in the way of the rockets? Get them out of there. Oh, this is so frustrating. It better not be like some cruise ship wandering into the launch zone. My goodness.
There appears that there may be a vessel within our clear radius. We're going to stand by to hear confirmation.
What
from
the
range.
heck? Honestly? I don't understand how the boats don't know. Like, this happens too frequently. That people just wander into the exclusion zone. Like, there better be some like crazy fine for people that do that. $100,000 for blocking the rocket. Yeah, whenever they call a hold, they always run the clock to T minus 70 seconds. So it's not that prophetic that if you guess that it would stop at T minus 70 seconds. But this means that, okay, so basically what's going to happen now?
And
Either
I
they're...
just got confirmation there is a boat in the range. We're going to stand by to see if they can clear the boat from our radius.
So it's going to take them like 30 minutes to clear that boat, probably. Yeah, they're going to probably try to recycle because there's nothing technically wrong. They just have to turn back the clock and redo the, you know, the lead up. You better not be in that boat. Trying to get a better view of the launch or what? Yeah, I think they're probably going to try to recycle. They have another hour and a half or so in the launch window, so they do have an opportunity to recycle, assuming they can get that damn boat out of there. And if the wind is now not good because of this, like what the hell? It'd be kind of funny if it's a boat that's like run by some other company is trying to block
Once again, just
relativity.
to clarify, our vehicle is healthy and all systems appear to be performing nominal. We just got to go for the weather for upper level winds, but unfortunately there is currently a boat in the range, so we're just awaiting confirmation to see if they can clear that boat in time and get it out of our radius.
I wonder how they actually go about clearing the boat. Like, do they just like radio it and be like, get out of the way? Or do they actually like fly out a helicopter and like signal to them like, go, get out of here? And are you allowed to just like refuse? Like, no, I'm a boat. I'll go wherever I want. I feel like they should just like permanently exclude like the water that goes to the east of Cape Canaveral. I feel like there's a rocket launch there like every couple of days. Like, you know, why would it be unusual for a boat to think that that water is not excluded? Just kind of weird. And it'll probably take them 5 more minutes to figure out if this is going to work or not. And then I suspect they'll probably give us a new T-minus time. They're still continuing to...
Announcement on countdown net is the LD. We got a hold called prior to terminal count. Hold gating items have been cleared. We are adjusting for a new T0 time. We'll hold the clock for terminal count until we pick up the count.
All right, now we are just confirming a new launch time. All items that were blocking us and giving us a red range have now been cleared out. So we're going to await that updated launch time and then update the T-clock above as necessary.
Okay, that boat must have just like briefly stepped into the exclusion zone if it got out that quickly. Yeah, they're very touchy about the exclusion zone. It's a very touchy thing. Like if you're like 2 meters into the exclusion zone, like that's a no-go. Yeah, they take safety very, very seriously at Cape Canaveral. I assume they're probably going to have to do some more wind estimation.
All right, and the clock is about to resume just shortly here. They are coordinating that new T0. We're very excited to get this thing
Announcement on
going.
countdown net. T-clock should pick up in 60 seconds.
60 seconds.
So they're just gonna roll the clock from T minus 70
We have confirmed our new T0 is going to be 14:42 Eastern. Once again, that's 14:42. We'll see the
2
T
minutes,
clock rolling
guys.
in just a moment here.
2 minutes. So basically, they didn't stop anything about the vehicle. The strongback is still retracted, so they're just gonna roll the clock from T minus 70 seconds in about 30 seconds from now. They have a weird thing where they don't like put the clock back and start like counting. They like hold it and then wait until a specific time and then start counting at that time. I find that a bit confusing. All right, maybe we'll finally get the clock down to below 1 minute for the first time. Here we go. It's going.
Close out.
We're less than a minute, guys. Here we go.
Computer and countdown. T minus 60. GC with the count. LD, are you go for launch? LD is go for launch.
And we just got that final go for launch from
we
our
go.
launch director. We are now just about...
Range green.
Range is green. We're now about 30 seconds away from the moment that we've all worked so hard for our first launch.
Here it goes,
We've
guys.
had a lot of fun with you, Terran 1. Good luck. And
Hopefully
here we go.
she leaves the Earth destined for the stars.
10, 9, 8, 7, 6,
Oh yeah, look at those engines.
1.
Absolutely beautiful. Ah! No! Oh no! So this is probably an automated abort. The engines were shut down. Okay. At T minus 0, they were shut down. So the engines started and they were
As
going.
you can see, we had ignition of our engines, but the T clock did hold at T0. We're going to stand by for updates.
They probably had some sort of pressure issue and something that the engines didn't like, and they basically shut down the engines before the launch clamps let go. Yeah, shoot. But all the engines lit properly. They were looking quite good. You saw there their quintessential bluish flame that comes from when they have when you have methane as the fuel. So everything seemed to be going properly. We just had a abort that was automated, like an automated abort happened at T minus 0 seconds, just before the clamps let go. Which is kind of like stopping it right before it could become a problem. Because as soon as those clamps let go, that's basically, yeah, there's not much you can do after that. Man, this vehicle is quite mercurial, I have to say. Always keeping us on the edge of our seats. I don't think they can recycle this. Once the engines have lit, I think that's pretty much it for the day. Unfortunately. But at least they got a good static fire out of it. You know, one more static fire for the Aeon engines. It's the first time they static fired it with the entire stack. Another milestone. It didn't blow up. That's good. Look at the positives, right? Yeah, short static fire. All systems nominal, except for a little bit there at the end where we didn't let go. Yeah. This is kind of similar to the H3 launch, the first one, the first attempt at H3, where they also aborted right before the clamps should have released. But c'est la vie.
All right, I'm hearing from Mission Control that we're currently assessing vehicle health to confirm if we can do a recycle today and try this thing one more time.
Man, they're still going to try the recycle, even after having lit the engines. Well, that's surprising. I don't think I would be bold enough to do that. But maybe those engines are a little more durable than typical. Maybe they're more like the Merlin, they can do all kinds of stuff. No, it'll take them less than 25 years. Come on. We've made progress. We went from T minus 70 seconds to T minus 0 seconds. So that means the next time it has to be T plus, right? Has to launch. Yeah, it's normal that the pieces of the rocket are falling off. It's just the ice on the methane and the oxygen tanks, because the whole thing is cryogenically, like all the propellants are cryogenically stored. So basically, all the water vapor in the air kind of like condenses on the rocket and then freezes. And when they ignited those engines, it created a whole bunch of vibrations, and basically in that vibration storm, all that ice gets shaken off. So yeah, it's totally normal if you see stuff falling off the rocket at this stage. I wouldn't be surprised by that at all. If you look at some of the Apollo launches, like the rocket was literally shedding ice, like for like 10 seconds during the launch. It actually kind of looks cool, in my opinion. Yeah, a recycle would be surprising. That I agree with you. I honestly don't think they're going to recycle, but I guess they still have hope. I mean, ultimately they're trying to make reusable vehicles, so I guess, restarting should be a part of the agenda eventually. But we'll see. Do you really get ice?
Countdown net. This is the LD. The aborted terminal count on a launch commit criteria violation at T-minus 0.5 seconds prior to liftoff. Are safing the vehicle and assessing recycle opportunities.
So the launch director is telling us that they're still analyzing and trying to potentially do a recycle.
As you heard, once again, we had a violation with our launch commit criteria, which is why we had an abort shortly before liftoff. The team is continuing to assess vehicle health to confirm if we can have a recycle today.
Yep. Okay. So basically the launch commit criteria, that's the thing that they said was violated. Essentially, there's a bunch of things that need to happen in order for them to release the clamps. And obviously one of those was not good. Usually they're engine related, to be honest. That's typically the problem. There's something wrong with the engines. But as far as we could tell, the engines looked pretty nominal. So I don't know. Maybe it could have been something else. It could be something as simple as, the vibrations of the engine in the upper nose cone were creating some sort of, I don't know, weird sensor data that caused them to decide, no, shut it down. Yeah, it could be anything. So we're just gonna hang on here and wait to see what exactly stopped the count, and if they decide to recycle or not. They could still decide to recycle this vehicle. They have 70 minutes left in their launch window, so basically they can turn this vehicle around and try to go for that. All they would have to do is basically fill up the vehicle with the extra propellant that was lost during the couple of seconds of static fire there, and they would be essentially ready to go. So they've basically grabbed back a hold of the rocket, as you see there, and they are currently continuing to fill it up. And you are seeing a big flare of liquid oxygen there, though, so maybe they're even starting to detank at this point. I don't know. It could just be part of the propellant conditioning, though, because it's not continuous. Yeah, I don't think they're buying their components from AliExpress. I can't say the same for Astra, though. We take what we can get.
As a reminder, we're currently at 14:50 Eastern Time, and our launch window is open until 1600 Eastern. So our teams are currently assessing any recycle opportunities that we have during this time.
They may still get a recycle opportunity. It's possible. However, unlikely. It kind of depends on the error that they had. I think it was good to go, though. They should have just let it fly. It wants to fly. It's like a caged up bird there on the launch stand. I wonder if they have another launch window tomorrow. They might. So we might see this vehicle back on the stand then, if they decide not to recycle. But yeah, that damn boat at the start, maybe whatever happened would have been solved by just that boat not being there. Maybe if they'd just, cycled into the count just nominally, as opposed to making that weird hold at the T-minus 70 seconds.
You'll see an occasional cloud coming out of the transporter erector or the black truss structure there. That is just because we're creeping our propellant topped in case we can re-attempt a launch before the end of the window today at 4 p.m. Eastern.
Yeah, I think I put the probability of a launch today down to like 10%, so yeah. If you drink a liter of vodka, I don't think you'll even care if they launch or not. Yeah, let's just hope the boats aren't getting in the way anymore. It looks like they're going to try to recycle to T-minus 45 minutes. So they're going to get one more shot at this. If they go back to that time, that this will basically be their last chance. This is very unusual, I have to say. Having lit the engines and they're still going to go for another shot.
As you can see,
Interesting.
the T-clock rolled back. We are still working on a recycle, so we'll keep you updated as soon as we have confirmation.
So not confirmation of a recycle just yet, but maybe they're still thinking about it. This is certainly a tricky one. This rocket is liking to tease us. I don't think I've ever been more excited for a first launch of a rocket before, to be honest. I'm really looking forward to this working. I wasn't always a fan of 3D printing, to be completely honest, but it's really grown on me. I bought a 3D printer about a year ago, and it really changed my whole perspective towards the possibilities with 3D printing. Yeah, there's just so much you can do with them. And after that, I've really seen the value and understood what Relativity was really trying to achieve. Because the only problem that I really have with my 3D printer is that the stuff that it prints is not metal. If only it could be metal. It opens up such a wide range of possibilities. So we're still awaiting information. For those who are just joining now, or maybe popped in and popped out every once in a while, we are in a place where, so basically we went all the way down to T0. The engines lit. The engines were going at 100%, but the launch condition, there's some launch condition criteria before you release the clamps. According to the launch director, those were not fulfilled correctly. So basically the vehicle decided no launch now and shut the engines down at T-0. What that means is that basically they are deciding whether they're going to recycle the vehicle or whether they're going to scrub for the day. They do have another hour in their launch window, and they have put the clock back to T-45 minutes, which means that maybe they're going to try for a recycle. But if they do, this will be their last chance. Basically, they would start the whole process all over again from the start, because of course they let some fuel out with the engines igniting and everything, and that changes the whole configuration of the ground stand, so they have to kind of start from the start again. Yeah, to be honest, this would be very unusual if they do decide to recycle, because it seems like an uncommon approach to this type of an issue. But you never know. This is a new kind of vehicle, 3D printed, right? Next technology. Maybe it can handle a little more, going with the flow than other rockets can. We'll see. Yeah, maybe that stubby nose is kind of a bit of a curse for the vehicle. It just needs that standard pointy nose cone, and then she'll be able to fly. No problem. But let's not say rest in peace just yet for the rocket. It's still alive. Everything has gone okay so far. We can't say it's over till it's over. It'll probably take them a couple more minutes here to come up with an answer as to what they're exactly planning to do. It does take them a little while to figure these things out, because whenever you have an abort like that happens automatically, basically you have to go through all of the data. Now that's a very big term. What does that really mean? There's literally hundreds of data points they're collecting every thousandth of a second when they do this. So there's pressure sensors all over the place, there's force sensors, there's temperature sensors, there's a bunch of sensors all around the engine, there's a whole bunch of different systems that are all working together at the same time, and basically they have, with a first vehicle like this, they have sensors everywhere. So what they're doing right now is they're looking at all that data to figure out, okay, what exactly was the reason why this thing decided it's not going to launch. And then trying to figure out, okay, is this a problem that we should address? We need to fix something? Is this a problem where we made a condition that's not really real and we can just delete a line of code and away we go? Or is this like something more serious where there's like a major problem that we need to like, scrub and come back another day when we can fix it later? And, they only have like 20 people in that room, and they have to figure that out like on the fly in minutes. So it's a bit of a tricky ask, a lot of pressure. Yeah, maybe the boat had a good view of the launch pad as well, seeing as they were in the exclusion zone. I wonder if it was like a private boat, or was it like a like a big boat? Like, was it like somebody's sailboat just like sailing into the wrong place? I feel like that's more likely. Just some random person sailing into the wrong area. It looks like they're still continuing to fuel the vehicle though. You see those clouds of vapor coming off the oxidizer tank, indicating that that's still occurring. So that's all a good sign. Maybe they're still going to try to recycle this thing. Anything's possible. There actually are a lot of things like the flight radar thing. Like so online flight radar is a website you can go to where you can see like all the planes that are registered in the sky and where they're flying and stuff. There's basically the same thing for boats, but of course your boat needs to have a transponder to be shown in that. So like if you just have like a motorboat or like a little motorboat or something, like that's not going to be in that program. So it could be that just somebody privately wandered into the wrong place. Yeah, so just to give you a little context as to what I have in my background here. So these are the propulsion grains for our small rocket, which is dubbed subscale right now. Basically, it's just paraffin wax in there that's been dyed black, and it's inside of a PVC tube. And this is going to be put into a carbon composite casing, which looks kind of like this. So this is the casing that will fit inside of. And basically, there's going to be some filler insulation material that makes it so that they all fit together. And that's going to form the combustion chamber for our first rocket. Yeah, we'll see how that works. We actually just made these propulsion grains earlier this morning, so I just came back from that. I don't know if you can see, but I have like PVC dust all over me because we have to like sand down those PVC tubes in order to fit them into our spin apparatus. But yeah, that's what we've been doing all morning. It's been really nice though because it's cold outside right now. Like I said before, it was snowing here in Bremen, so we were able to actually make 2 of these grains in like 5 hours. So we had some good progress for getting some work done today. And all of these grains are going to be used basically for our propulsion testing, which we're going to be doing in May. So we're basically just preparing, getting ready for that. Yeah, basically they are like, I mean, they're just PVC tubes. So essentially they're the water pipes that you sell, that you get at the hardware store. We literally bought these at the hardware store. So it was like, $10 for a 2-meter long pipe, and we just cut it up into the dimensions we want, and boom, there you go. That's your basically your material that you can use to spin your grain in. Yeah, it's really, try to keep things simple as much as you can. You don't have to get too complicated about it. I don't think Elon's much interested in the hybrid rockets world. Unfortunately, our technology is not that advanced. Again, just keep it simple, nothing too complicated. Yeah, SpaceX is much further ahead of us, I assure you. And we're not afraid of people copying us, We're happy to share all of the knowledge that we have, any ideas we have. I want everything that we do in the ASTRA team to be public knowledge. There's nothing secret about rockets. Rocketry is for everyone, and I think that everyone should have access to the information to be able to pursue their dreams of going to space. Yeah, that's our vision. We are not using ammonium perchlorate composite propellant, so we don't have to worry about that. I assume you would need a license for it in Germany. That's not something that is taken lightly. You might not even be allowed to have it in Germany. Germany is super tight on oxidizers of any kind, because of course you can use those for weapons, and yeah, that's not something that's typically easy to get in Germany. In the US, I'm not sure. I'm pretty sure that it's easier to get, because I've seen lots of amateurs that use ammonium perchlorate in their solutions. So I assume that you can get it, as long as you have the right credentials. You could probably ask your local amateur rocketry association, like Triple E or something, about how you can get access to those types of propellants. They'll have I'm sure they'll have the path that you need to go forward in order to do that. Yeah, in the EU it's difficult. It just is. However, you can get access to HTTP as long as you are connected in the right ways. There's a rocket group in Stuttgart. It's called High End, and they're actually using a hybrid system which uses an HTTP fuel grain. So that one is maybe a bit more possible. I don't know. Yeah, I guess guns are illegal, so yeah, APCP. Although technically, you could probably do a lot more damage with ammonium perchlorate than you could with a gun, so just saying. Yeah, if you're in Pakistan, then I don't know. I guess there's no local amateur rocketry. I was more speaking if you were an American. Yeah. In Pakistan, I have no idea how you get ammonium perchlorate. But I'm sure, I don't know. You get it online? Maybe? I don't know how tight they are there. So for those that are maybe just joining, or for those who want an update, we're here in a hold right now. The rocket ignited its engines, just before T0, and everything was going well, but at T0 it didn't release the rocket. Basically, the conditions that are required in order for the rocket to release the clamps were not fulfilled, so they stopped the vehicle from actually taking off and shut down the engines. And now we're just trying to see if we can recycle the vehicle or not. So they put the clock back to T-minus 45 minutes, which I assume is the amount of time they would need to recycle. We have about 50 minutes left in the launch window, so we're kind of getting into the critical period as to whether they're actually able to feasibly recycle at all. If they don't give us information in the next 5 to 10 minutes, then we will know basically this is an abort. Yeah, if you can get access to metal 3D printing, I would if we as ASTRA, as an ASTRA community, got access to 3D printing, we would definitely stop with hybrid, to be honest. Hybrid is kind of like the mix of all the difficulties from liquid, but all of the challenges of a solid. You kind of have both the problems in one. Sometimes it's almost nicer to just stick to one or the other. But at the time, it seemed like when we first were designing our rocket, we kind of thought that, well, hybrid is kind of like a safer solution, because the oxidizer and the fuel are not like near each other until you're launching the rocket. But you know, hindsight's 2020, and you kind of learn about that stuff later. It looks like we've just started the clock, guys. We're counting down. I think they're going to recycle.
The T-clock is rolling again, everyone. We just have an updated launch
Here we
time
go.
of 15:55 Eastern.
Come on,
Once
Terran
again,
1.
15:55 Eastern in just under 44 minutes. We're going to keep going.
This is fantastic to see. It looks like we're going to go through the whole process all over again. So we're going to start at the very start, roll the clock from T-minus 45, and see if we can get this launch finally happening. So if we count all the attempts they've made in the last couple of days, this is now number 6, I think. Number 6. 6 times the charm. Yeah, 45 minutes. Yeah, I guess this is going to be a long wait. But hey, we can chat in the meantime. One thing that I know you can do is I think you can actually buy like solid motors off the market, like commercial off-the-shelf motors that are quite high power, and I think some of them actually use ammonium perchlorate. So if you have like the level 1, level 2, level 3 amateur rocket certification in the US, you can actually purchase motors off the shelf that are reasonably powerful. So the trick is to go and get those certifications at your local amateur rocketry association location and move up the ranks and then upgrade to higher and higher and more powerful rockets. Although keep in mind that will hurt the bank account a little bit. So, something to think about. It's not a cheap hobby to have. Yeah, you can also buy them in the EU. That's true. But again, you will need to be in some places you will actually need to have some sort of credentials in order to do that. Like they won't just sell it to anyone. So keep that in mind. SpaceX should open an office in Pakistan. Yeah, something tells me that might not be what happens. Although there is something to be said for maybe India, because if you think about it, like they want to launch, like if you're launching a rocket to geostationary orbit, it's actually better to launch the closer you are to the equator. So being in Florida is actually not the greatest because you're actually 28 degrees like away from the equator, which means it actually takes more fuel to get up to geostationary orbit. So you could actually take more mass if you actually launch closer to the Earth's equator. Yeah, like I was saying before, like if you want to buy commercial motors off the shelf, like it's going to be expensive. So you have to consider that when you're deciding to do that. But if you want to, you know, get ammonium perchlorate, you know, motors that are going to be reliable, it's probably not a bad way to do it, to be completely honest. And they're probably going to do a better job of making that motor than you ever will. So, I mean, it's like their business, right? Yeah, that's true. For Yurok, basically, you just send them what you need, and they kind of go through the process of getting you the motor for you. Because the rules are a little different in Portugal, it's a little easier to do stuff there. Just saying. Things are a little more lax. Which is actually a really fantastic thing because, like, this is not good. They just put the clock back to 45 minutes. What does this mean? Okay, they started it rolling again. I assume that means they're pushing back to the end of the launch window, which is at 9 o'clock UTC. Interesting. Okay. Yeah, definitely go ahead and get your level 1 certification. That's the first step. And it's cool to get the opportunity to do more stuff.
From our engineers and mission control, we are updating the T0 time to 1600 Eastern. Once again, that is 1600 Eastern. T clock is rolling.
So they're pushing right to the very end of the launch window. Literally, this will be their last chance. There will be no opportunity after this. Oh man. This if this rocket launches, then man, okay. Streaming from Nigeria. Wow, excellent. Great to have you. Great to have you, Ahmed. the boat's not gonna come. Come on, guys. Don't jinx it like that. You know, Transcendence might just launch before. You never know. Although, to be honest with you, Transcendence was originally supposed to launch in 2023, and that's not going to happen. So we're just as bad as they are. No motorboating inside of the exclusion zone, please. Thank you. We would like to see this rocket launch. I've been a spectator for too long. Out of curiosity, which computer are you gonna, like, flight computer are you gonna use for your deployment of your parachute? For us, we're just using a Raspberry Pi and a bunch of sensors attached to that. Guys, we gotta stop talking about motorboats. We don't want boats inside of our exclusion zone. How are you melting that silver? Do you have like a furnace or something? We just got a furnace at ASTRA to help us make some of our metal components, and so far it's turning out pretty nicely. We made a nose cone a couple weeks ago out of aluminum, and it turned out pretty nice. And we're hoping that maybe in the future we're going to upgrade that to an aluminum bronze nose cone, which will be able to withstand the heating on the way to space. But we'll see. Ah, you're the one with the aluminum bronze idea. Very good. Yeah, we've definitely taken that idea. We've stolen your idea, and we're going to use it because it's actually a really good idea. We already played around with it a little bit. I made a couple of aluminum bronze concoctions already. My first project was just my first project was I just made a bracelet just to see like if we could pull it off, and my smelter was hot enough to actually do it, and it turns out it worked. So I think we're going to go ahead and see if we can make the nose cone out of the aluminum bronze. Yeah, better to play it safe than sorry. because the aluminum will definitely get a bit toasty. I don't know if any of you guys saw the video that BPS Space did, because he actually put a bunch of sensors into his aluminum nose cone and got some results with like how hot each of the parts gets. So if you haven't seen that, I would definitely recommend it, because it definitely turned up some interesting results. He didn't go like to supersonic speeds or anything, but still at subsonic speeds you can see like the heating profile over time of the nose cone and all the different parts of the nose cone. He had like 4 different sensors in the nose. So it was actually pretty interesting.
For those of you that are tuning in today, we're going to take a moment again to introduce ourselves. My name is Rachelle Aniceto. I am the Chief of Staff for the Vehicle Architecture and Technology team.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch here at Relativity Space. Now, ahead of Terran 1's liftoff, we invited some of the most influential voices in the space industry to curate some questions from you all on Twitter about our journey to launch. We appreciate the time that Michael Sheets, space reporter at CNBC, Eric Berger, senior space editor at Ars Technica, and Tim Dodd, the everyday astronaut, took to answer your questions. Let's take a look.
All right, so
this question comes off of Twitter from Danny Stover. Many launch companies fail their first attempt. Will Terran 1 reach the same fate? What makes Relativity's approach different? I want to hear, Michael, what do you have for that one?
Many companies failing their first launch attempt is, I think, a great example of
this one better not fail.
High-risk aspect of the development.
This one's not going to fail. Come on.
I think that's one thing a lot of people need to keep in mind is there's along the way to development, even before launch, there's all these milestones that you're trying to get through, including, as we've seen recently, static fire. So you pass those milestones, you get more data. As you move closer and closer, the end goal is, can we not just get into space, not just get into orbit, but deliver into the targeted orbit, get to the place we want to actually be. And I think a nice analogy of it is like ordering an Uber. You want an Uber that's going to get you the closest to your destination, ideally your front door. But if your Uber is dropping you off, a couple miles away, you're probably not going to continue, using the app anymore, because you're going to try to go with a competitor who's actually getting into that ideal.
Yeah, I didn't know about a guy that's starting up a hobby rocketry company in India, but it's probably a really good idea, because there's definitely a lot of interest in India, at least, for like hobby rocketry stuff. Like half the ASTRA team is composed of Indians, actually, interestingly enough. A lot of the students that come to the University of Bremen actually come from India. It's quite an international program that we're in right now, so people come from all over the world. Yeah, there's definitely a huge desire for that in India. So I think it's a great idea. Maybe they sell stuff for a little cheaper too, which would be nice. Because some of the other commercial off-the-shelf stuff is somewhat expensive for the hobbyist community.
We'll see that get through max Q. And then there's some more complex elements on the Terran 1 rocket that you might see in a more traditionally developed launch vehicle. And so I think seeing a nominal first stage performance would be a pretty big win for Relativity. And I'd love to see them get to orbit on their first time out. I just think historically the odds are pretty long against it.
Yeah, I'm definitely with Eric there. I realized just recently that the Pegasus.
Yeah, ideally the rockets shouldn't be ever plussed with boats.
But realistically, like Eric said, the odds of being completely successful on the first round is statistically about 0. So I'm just excited to see if they can get through the first big milestone. If they can, make it through max Q, if they can see stage separation. Each staging event is definitely one of those big unknowns until you do it for the first time. Can you light your upper stage engine? Can you, deploy your fairing?
Yeah, Falcon 9 does land on a boat, but you have to remember back to the old days when That Falcon 9 destroyed that boat on numerous occasions, and sometimes the other way around. So making those two work together is quite difficult.
But, of the company we talked about, only Rocket Lab got to like a second stage engine ignition and flight, right, on their first mission?
Yeah, he's correct about that. Like,
Yeah, 21st
almost
century wise, that's definitely true. And I think another way to tackle this question is defining failure, because when you talk about many companies fail their first attempts, you need to understand the multi-step process of a rocket launch. And I think that's another important aspect where, depending on how far they get towards their ultimate goal, will categorize whether this is a learning experience from a failure standpoint, or this has a lot more to build upon. And every step that they complete during the launch is another check mark towards success.
Yeah, absolutely.
there's definitely some German and French hobby rocketry for sure, but not necessarily high power rocketry in those areas, because it's really tough to like have a high power launch where you're dealing with like altitudes that are going above a kilometer or so. Yeah, all of these rocket companies are hiring, just so you know. Like, seriously, like Rocket Lab, Relativity, Firefly, Blue Origin, even SpaceX. SpaceX is always hiring. So like if you want to participate and you're American, like this is the time. Send in your application. Yeah, not only in America, but also in some of the rocket companies around the world. There are a couple of rocket companies here and there in different countries. They're also looking for new people, so it's not like it's just in America. I'm not really sure I understand your joke there with the Russian and the American rocket.
This is an impossible question to answer.
I assume you're referring to the
rockets are capable
to how they were all started by German scientists.
And that's the great thing. What I love about the launch industry today is you've got all these companies trying different things, right? You've got ABL out there trying to basically build a miniature Falcon 9 as simple as possible.
Wait, is the Rocket Lab launch actually going now? Man, I've actually lost contact with that one. I guess it's going, yeah, it's going, I think they delayed it by a day already though. Yeah, the Electron one's not going in a couple hours. It got delayed.
Sure, ultimately.
I'll do this one. This one comes from Kyle A. Mabe asking, what other markets in the space sector or beyond do you see Stargate technology being applied in? I kind of mentioned it earlier. I would love to see, large scale additive manufacturing be used for, automobile prototyping, race car prototyping, especially. Oh my God, like the Formula One world where every year the cars have new restrictions.
How about like space station building? My goodness.
Set of rules to have to engineer by. Being able to at scale develop stuff with a 3D printer makes all the sense in the world. So I think that's a pretty no-brainer would be the automotive industry.
I think there certainly are.
Yeah, Rocket Lab operates mostly out of New Zealand. So, or they used to anyway. Now they're doing more stuff in America. Now that they're trying to open up this Virginia launch site. So, yeah, there's also jobs in New Zealand as well. I'm not sure if they actually have like engineering jobs in Canada. I thought that was just like, I'm not even sure what they do in Canada.
Sectors can look, where can we apply this? Where can we iterate faster by implementing printing these as solid entire structures, as opposed to different pieces that you put into whether it's for shipping or other large industrial components. You can see the kind of downstream effects of basically a demonstration of, hey, we can build a rocket with this type of technology.
The one thing they're going to have to work on with respect to the 3D printer for like other applications is trying to work on the resolution. I don't know if you can tell, but in some of the 3D prints that they have online, you can totally see that the resolution is not like fantastic. For a rocket, it doesn't really matter because, you know, it's just like a slight aerodynamic thing and it doesn't really make that much of a difference. But I think for like a car or something, it might be a little more of a concern, especially for Formula One.
To housing units or things like that. But it's going to be fun to find out where this technology goes.
And printing your house in aluminum would definitely be expensive. I don't know if it's going to be used for that. I think it's more cool to see it in space.
That was a great video answering some of your questions on Twitter. Now we are at T-minus less than 30 minutes from our launch with our updated launch T0 time of 4 o'clock p.m. Eastern. So that is 1600 Eastern. We're currently going to stand by from an update from Mission Control in the next few minutes.
So yeah, Mission Control will give basically an update as to whether the vehicle is still a go. And I assume that the weather and the range will be included in that update. That usually comes at around T-minus 24 minutes or so. And then we're going to go into the go no-go poll, which is going to be at T-minus 15 minutes. And pending that being successful, the vehicle goes into basically the final countdown operations from T-minus 10 minutes. And stuff starts to happen really with the like strong back retracting and everything at T-minus 3 minutes. So those are kind of like the key milestones, I would say, along the countdown. Hopefully we're going to see some of them, them all get past this time. Again, last time we did make it down to T-minus 0. So right to the point before, like literally milliseconds before those launch clamps let go. And the reason why they didn't is because there was some sort of condition that was out of range. And the computer decided no launch today. Or maybe still a launch today, but no launch in that moment. But the engines did ignite. They just were shut down. And then basically they decided to recycle to the very end of the launch window, which is in 28 minutes. And lo and behold, the count is now just under 28 minutes, ready for the launch. And this will be an instantaneous launch window. If they do not get the chance to launch there, they basically will have to scrub for the day. So yeah, Rocket Lab. Rocket Lab has engineering interns in Toronto. Oh, I didn't know that. Interesting. I don't know if I would like that so much, because if I'm an intern, I want to be like in the facility where they build the rocket. I don't want to be like far away in a different city. I don't know. Maybe that's all the rage these days with the hybrid working, you know? But yeah, just to give a little bit of context, Rocket Lab is the only company who has actually gotten past the first, like who's actually successfully gotten to the second stage burning on their first launch attempt. Like for these companies, all private companies, the first launch usually fails. So, yeah, maybe Relativity will be the first rocket to successfully complete all their mission on the first launch. That would be crazy. To be honest, I have a lot of faith in the Relativity team, so they might just pull it off. So we should be coming up here pretty soon on the quick update from the launch director about the initial thoughts on whether they're going to be a go for this last attempt or not. Hopefully it'll be all green and we can proceed. After all, we have been waiting quite a while for this. Still looks like a beautiful day in Florida, so we should, if it does launch, we should get some really nice tracking shots, and we should see some good images of the first flight of this vehicle, which is what we really care about. We want to see this rocket launch. I would love to be there right now. Minus the whole, maybe it'll launch, maybe it won't situation. But other than that, it's a very gorgeous day there, I have to say. So let's listen in here and see if we get any information from the launch director. For those just joining, this is again the launch of the Taran 1 vehicle, which is made by Relativity Space. It's a completely 3D printed rocket, which makes it a bit unique in the launch market. It's been on the pad now for about 3 hours in the ready to launch configuration. We're just getting to the end of our 3-hour launch window. The clock is now at T-minus 24 minutes, so we're 24 minutes away from a potential launch. We're just waiting on some information from the launch director as to whether we are still a go for today. This rocket is 100%, or not 100%, it's 85% 3D printed aluminum. So it's quite a large volume of the rocket that is actually made with a 3D printer, which makes it a bit unique in the world, as it is actually, I believe, the largest 3D printed structure on Earth. It just happens to be a rocket. Yeah, I agree with you. In general, if Relativity does fail on this launch, it's not a huge deal, of course. It's just part of the process. But I think it would be even cooler if they pulled it off. Yeah, you have to keep in mind that Firefly Aerospace's launch vehicle is very different than Relativity's. Relativity is a very unique vehicle. It's a whole different approach to rocket technology and rocket engineering. So if this thing completes its mission on the first try, that just goes one step further to show this is something that vastly simplifies rocket science and makes it more reliable. Like, imagine that. Like, if we can simplify the amount of parts that go into a rocket, you can actually simplify all the failure points as well. And maybe that's the big step that we need right now in order to make rocket launches less of a anxious moment where we don't really know what's going to happen, to being something more like an airplane flight where it's like, yeah, is this the safest form of travel? So just because other companies fail in their first launch, I wouldn't necessarily expect that would be the case for Relativity. This could be something different, and that's something to keep in mind. Yeah, if this thing gets off the pad, I think that's obviously a good first step for a launch vehicle. But I have great expectations. Yeah, maybe rocket science isn't that hard after all. You never know. You just need to invent a whole 3D printer, revolutionize the art of manufacturing. But once you solve all those problems, then rocket science is easy. Yeah, ASTRA, the commercial rocket company, also failed their first launch. If you remember, it ended up going a bit sideways, literally. Maybe one of the coolest launch failures that ever happened, in my opinion. But yeah, no matter what happens though, they're gonna get some interesting data, and they're gonna be able to come back with a better vehicle. I can promise you that. And because they 3D print it, like it's not gonna be that difficult for them to iterate. Like, they can literally just 3D print a new one, like pretty quickly. Their target is to be able to 3D print a new one within 60 days. Like, that's their goal that they want for the organization. So I'm like, the idea is that they can pump these out real fast. Yeah. So we just passed the T minus 20 minutes, so that's a good sign. We're going to be moving in on their go no go poll pretty soon here. So that's going to happen at T minus 15 minutes. Hopefully they'll let us listen in to the launch director and the mission control room while they do that. You're already back from melting the silver? My goodness. You must have a very powerful furnace. Mine would take like 30 minutes to get up to temperature. I just use an electric one, so the propane ones are obviously a lot faster. Yeah, a propane torch and a melting dish. Okay, obviously that's going to be a lot faster than what we got going on here at ASTRA.
The go no go polling from mission control is coming up here in just a couple of minutes, around T minus 16 minutes. We're going to stand by and continue listening in, awaiting that poll.
Well, as you all know, 3D printing is an activity that takes a lot of patience. So maybe that also ends up being the case for the rocket as well. Lots of patience. But everything seems to be nominal, so hopefully we're still good to go here. What are you planning to do with that silver, out of curiosity? ASTRA doesn't have much use for silver because it's not really a mechanical metal. We're mostly just working with aluminum. So the go no go poll is going to come at T minus 15 minutes, so we're just 2 minutes away from that. This is going to be basically a critical milestone to see if this thing is ready. I suspect it's just going to be go all around, because at this point, what's going to stop it? I don't know. Investing in metal is always a bit weird to me. I find that an odd way to store value. Like, I'm just going to buy a bunch of shiny metal. I don't know. Yeah, so basically the vehicle is on, well, it has been on hold now for almost 3 hours. So I think they're going to the no-go poll here pretty soon, but we'll see. Yeah, the vehicle's been on hold for about 3 hours. They tried to launch. They got all the way to T minus 0. The engines lit, and then the launch clamps didn't let go, and they shut the engine down. And the reason for that is that the launch conditions that they need in order to let go of the clamps were not fulfilled. Not really sure exactly which condition was not fulfilled, but regardless, they decided they could recycle, and they set the clock back to T minus 45 minutes, and now we're just in that final phase. We're coming up to the end of the launch window here in 15 minutes, so basically this is their last chance. If they do not launch it at T minus 15 minutes, we will have an abort for today. I put the chances of launch at this point pretty low because maybe like 15% or so. Everything's got to work perfectly. Yeah, so the engines did light up. They lit for about 2 or 3 seconds, and then they shut them down. It's possible to shut them down like that. You just have to stop the flow of methane and oxygen into the combustion chamber, so it's pretty easy. But it was a little bit weird that they're going to recycle, because usually once you light the engines, that's like, usually that's an abort. Like, usually you abort. But apparently they're good to go for a recycle, which is certainly a strange way of operating. But hey, this is a new vehicle. They have a new way of doing stuff. Yeah, I would love that if if eventually in the future we're mining asteroids and we're yeah, getting the prices of the metals down on Earth a lot lower. That's going to be huge. There have been quite a spike in prices for raw materials, so if asteroid mining could bring that down, I would be quite happy about that. But yeah, watch out. In about 50 to 100 years, I think that's going to be huge. Asteroid mining. Once the price of launching mass into space drops lower than the price per kilogram of the raw materials that we find on Earth, that's when there's going to be a huge shift. And I would say we're getting close.
This is the go, no-go poll for launch. Please provide concurrence for proceeding the launch operations with go, no-go.
So they're going to go through everyone right now and see what the go, no-go is. Anytime now.
Go. GNC. Flight software. Prop 1. Prop 2. Boots 1. Boots 2. Loads. Rock.
Ranges go.
OSM. RC.
RC go.
Vehicle. CE. LC. LC go. All parties are reported go for launch countdown.
Looks like everyone's a go. So
right,
we're one step closer.
Is being relentless here. We are not giving up, and we're going to give this one more shot with an instantaneous window at 1400 Eastern. As you heard, all parties have reported they are go for launch.
Okay, here we go.
And just a reminder, 1600 for that launch. And as we continue to wait, let's remind you what we have inside of our nose cone. So we don't have a customer payload on board, but we do have our special memento, which is our first ever 3D printed piece from our Stargate.
Let's hope it's not so fireworky.
Before, it was a failed print.
I kind of bank it on this one to work.
As we get to this moment. As a reminder, that piece is about 6.5 inches in diameter and weighs about 3 pounds, and it is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we added a machined centerpiece with GLHF and our mitosis logo to commemorate this maiden launch.
So yeah, it's really cool that they choose this as their payload. I think that that's an interesting thing to put into your payload for your first launch. Harkening back to the first days of your launching. Yeah, there is an asteroid with a bunch of stuff in it. It's called Psyche. What is it called? Psyche something. I forget the number. But NASA's actually going to send a probe to it, and I think that the Falcon Heavy is going to launch it, or Falcon 9. One of those is going to launch it. And I'm actually really interested in what that's going to be. It's going to be interesting. I don't really know what this alloy is that they're using, but it's one that can be 3D printed. And that's what's special about it. And they keep talking about their, like, how it's a alloy that they've patented and is special. I think it's just that they can use it for the 3D printing. And yeah. I mean, if it has the same mechanical properties as other aluminum, then I mean, that's fantastic. Yeah, the Europa Clipper mission is going to be pretty cool, because that's actually going to do a bunch of crazy science with Europa, which potentially is a place that might have life. So I really would like to.
Countdown sequence has started.
Okay, so we're down to T minus
You
10
heard that
minutes.
call out. We're
This is
currently
good.
at under T minus 10 minutes, and in the upcoming minutes, once again, you're going to hear several call outs from Mission Control as we go through the final pre-launch procedural steps, including priming of the igniters, final engine checkouts, transporter erection retraction, and getting that final go for launch for this attempt. Again, we're now
So
pressing the
stuff is going to start happening, and at about T minus 3 minutes, that's when the strong back's going to retract. So watch out for that. That's going to be the next big move, I guess. Yeah. So yeah. As far as cool payloads go, I think that they've chosen a cool one as being their first thing they printed. ASTRA is actually has a special traveler, which will be going on the Transcendence rocket, which is basically a little stuffed plushie octopus called Octavia. You may have seen her in some of our videos if you watch carefully. She's going to be the first octonaut to get to space. So that's going to be Astra's big milestone for reaching space. I'm glad that you've had a good time while you've been here. Yeah, if it does fail, I mean, at least we got to talk about rockets for a little while.
Stage 1 will be transitioning to helium shortly.
Yeah, Titan is also a cool moon, but we've already sent something there. We've already landed on that moon, so I mean, we should send more stuff, of course.
Transition to helium.
But I think we got to send something to. We got to
Once
land on
again, that means
Europa
we're
at some point.
pressurizing the propellant tanks to flight pressures with helium, and as a reminder, during flight, we'll be pressurizing
chill.
using autogenous pressurization.
So it looks like we're rolling through this process
Tanks
pretty
are
quickly here.
pressing for engine chill.
The engine chill is just something that they do in order to get the engines down to cryogenic temperatures, because running the fuel through it at cryogenic temperatures when it's at room temperature is like potentially a problem. It can cause stress on the metal that could damage the hydraulics and stuff. Yeah, Huygens was the one that landed on Titan, and it flew on Cassini. It was like one of the side missions.
Since we're getting
so to say.
into the business end, let's remind you about our launch timeline. Arwa, take it away.
So again, at T minus 3 minutes, the transporter erector, or the black truss structure behind the vehicle, is going to retract just a few degrees to give the proper angle for umbilical separation. At this point,
Yeah, the Dragonfly is going to be a cool mission. But I think it's one that's going to be worth being patient for, because it's literally going to be something that's going to fly around Titan. Like, it's going to be crazy. Like, imagine all the science they're going to get to do with that.
flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T minus 6, we're going to see that ignition one more time of those 9 Aeon 1 engines. So you'll see the flames, the blue fire, I should say, beneath the rocket.
Stage igniters priming in.
And at T0, we'll have liftoff. At T plus 2 seconds, the strong back is going to throw back to remove the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program. And then at T plus 80 seconds, we're going to reach max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff. That is where the stage 1 engines will shut off, and it will be followed shortly by stage separation and Aeon vacuum engine ignition. Our second stage will burn for a little under 5 minutes. Then at approximately T plus 463 seconds, we'll get to second engine cutoff when that Aeon vacuum engine will shut off. And as a reminder, we do not have a fairing or any payload deployments for today's first launch. With that, we'll go ahead and sit back and listen back to Mission Control.
All right, guys, we're down to the last 5 minutes here. Keep up the hope. This vehicle needs all the positive energy it can get.
The igniters with gaseous oxygen and gaseous hydrogen. Again, our ignition system uses these propellants flowing across a glow plug.
Everything is going nominally. Yeah, the Dream Chaser is another cool vehicle.
Less than
coming up
5 minutes away.
pretty soon. It's going to be one that can take people. But it still has to fly on a rocket. It's not a single stage orbit or anything.
Igniters priming in.
So these are the igniters that are priming. For some reason, they take 4 minutes to do
our
that.
maiden launch. So a nominal flight would have Terran 1 reach orbit today, but our main goal is to learn as much as we can about this vehicle and demonstrate the product concept. A major milestone would be for us to reach max Q today, the point of maximum dynamic pressure.
That's going to be at around 80 seconds into the flight. So
Stage 2 is on internal power.
that's basically the point where they're verifying that their 3D printed structure is able to withstand the stresses of rocketry.
TE cradle, there we go, disengaged. You'll see that cradle arm slowly start releasing stage 2 so that the strong back can retract.
So that rail is basically going to start moving back now. Strong back is what they call it. It's kind of like the Falcon 9 launches in the old days. Now they're doing the thrust gimbaling just to check to make sure that the engines are able to gimbal.
And you can see the engines gimbaling there. We're performing the final thrust vector control health checks on both stages right before liftoff. You can see stage 1
is on internal power.
Engines there.
Come on, guys, no negative talk. We're in the last 3 minutes.
Strong back retracting.
And now that black truss structure will retract just a few degrees to prepare for umbilical separation. There it goes.
No boats. No boats allowed.
Stage 2 TVC checkout.
Oh man, I really want this to launch.
As we approach T-minus 2 minutes, just a reminder, the vehicle you're looking at is 85% 3D printed.
It would be huge if this works.
Those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid air that we have here in Florida. That's why it condenses into vapor and it looks like clouds that are floating out. You'll also see the flare stack on the bottom right there. That is just used to vent out flammable gases.
Okay, we're coming up to the T-minus 70 seconds. That's 110. That is the critical zone.
Next up, our range coordinator will ask the range for their final status.
Better be no boats.
Rock, report range status. Range green.
Fantastic. No boats.
We got confirmation. Range is green for launch.
Propellant topping close out.
Rockets don't care about the birds. All right, guys, last minute. Here we go. Let's go, Taran 1. This is the time. Uh-oh. No. Why is it stopping? Ah, shit. This is an abort.
Final countdown, that is the LD. We've had a board internal count. This is a final instantaneous T0 launch window.
Yeah.
We are going to be scrubbed for the day. Safety of the vehicle. Thanks for playing.
So that's it for today, guys. That was the last moment that they had. They can't recycle. Oh man, when is this thing ever going to take off? It is a tricky one. It doesn't want to fly. It's a cantankerous beast. Okay, so basically this means that they're going to they'll be abort for the day. So they are going to obviously arrange another time where they can launch this. It's probably going to be in the next couple days or so.
Our teams obviously gave it an amazing shot today, and we had high hopes for sending our Terran 1 off, but we're going to continue to take a measured approach so we can ultimately see this rocket off to max Q and beyond.
Once we have an update on the timing of our next launch attempt, we will share that via Twitter at Relativity Space. We hope you will join us again soon to see the world's first 3D printed rocket fly. I am Rochelle Aniceto.
And I'm Arwa Tizani Kelly. Thank you. See you next time.
All right, guys. So that's it for the day. It's been a long one. Yes, this rocket's gonna fly. Don't worry. Yeah, it just takes time, you know. It's a new vehicle, so it's you know, it takes time to get these things figured out to make sure that, you know, all the stuff's working and working nominally as we expect it to. Yeah. Just stay posted on their social media for their next launch. We will do our best to hopefully stream the next attempt. Again, I'm really excited to see this one launch, so I don't want to miss it. I hope you guys are as excited as I am. It could be a big monumental achievement if this thing is able to take flight and achieve what they want it to achieve, because the 3D printing technology is really something that could truly change the world. So yeah, hopefully they get past T0 on the next one. In the meantime, guys, I hope you guys have a great rest of your weekend, and remember to keep expanding your horizons.